All right, good morning, everybody. Good morning. Can you hear me? Can you see the screen?
Morning, sir. Yes, sir.
All right, so what we're doing today is what I believe will be very beneficial. In fact, what I know will be very beneficial to your exam coming up. What I have here is a compilation of AdMaths multiple choice questions. Basically compiled over a number of years and basically covers all the possible ways that CSEC could set AdMaths question, all the possible ways. And the source of these questions are from all over the place, from GCE, from within schools, from own questions, from all over the place. And it is set out topic by topic. And the aim is to do it one topic at a time, so we can have a focused approach. And we will see if we can actually finish it today. What you'll find on it also, we'll find out we have functions on it. I'm going to skip over the functions. Because function is no longer on the syllabus. When I say functions, I mean like the f of g, composite function, inverse function, and stuff. I don't mean like the quadratic function and linear. I don't mean that or cubic function. Right? I'm talking about straight functions, one-to-one and all these things, many-to-one and all these things. Right? So I guarantee you can understand the solution and the way to do each of these questions. You will have a very, very easy and good time in the exam that's coming up. Guarantee you. All right. This will be like the Bible in preparation for that exam coming. If you stick to these questions and stick to this that we're gonna go through now, in the exam, you will have a very easy time in those exams. That exam, guaranteed, without a shadow of a doubt. All right. So I can do the paper from front to back, but I can also do it topic by topic. Right. So one person said I should maybe start with series and sequence. All right. So the questions here are in the same order that syllabus laid out in terms of how the questions will be set in the exam. So the sequence of questioning here is in that same sequence. But we don't have to go according to that sequence. We can go topic by topic in terms of preference. Right? So persons can indicate to me which topic they would maybe want us to look at first. I'm going to start with series and sequence, AP, GP, and so on. So those will not start at the beginning. We have polynomials at the beginning and quadratics. Right? So just wanted to give some background of what this is all about. And the main takeaway from all that I've said really is that if you stick to this set of questions that I'm giving you today, right, then you really don't need any other work. You don't need any other source of questioning. I guarantee you that. Right. So I have it scheduled for 2 days, but if we can, stick it out and get through it today, what it means is that you'll have tomorrow and so on to, go back over and practice by yourself rather than coming back up to watch me go through questions again. There's one other important thing that I always say to students when it comes to multiple choice, and is that it's something that people just, they don't focus on that. They tend to ignore the fact, and this is the fact. The answers are there on the paper. And oftentimes we find yourself working the question and not giving any attention to the answers. So when you read a question, you should always look at the answers, see the format of the answers, and you know the extent to which your solution should go. Also remember that in this exam, you are free to use your calculator. A lot of the times you're trying to work out the questions as if you were doing a paper 2. No, I don't need to show working, You just need to get the correct answer. So a lot of the questions are new. A lot of the questions will be numeric. meaning the answers are numeric answers, values. And so a lot of them can be worked out with a calculator, especially like the tricks question and so on. So when a question that can be solved with a calculator, use a calculator to solve it. I can show you the way to do it other than using the calculator. But remember that in this multiple choice exam, you can use your calculator, and where you can use your calculator, you should. Just use it the right way. All right. So when I come up on some of those questions, I'll show you. I show you the way that you would solve it on a paper too, if you want to show working. And I might show you then how we can just do it with the calculator. Oftentimes we don't think of doing it with the calculator, but yes, the calculator can be used to solve a lot of these questions quick and fast. All right, so let's go. We're gonna jump into series. Remember, this is a revision program, it's a revision session. So we're not really teaching anything from scratch. The assumption here is that you already know the topics and you already know the content, and you just want to see how the questions can be structured, how you would work them out, right? And get a feel of what the multiple choice questions will be like and how to do them. All right, so we're gonna move down to series. So you see me skipping over and I'll mark on the page the ones that we do. So the first section here is really polynomials, and it goes into quadratics. And I'm looking for series. So I'm going down, I'm looking for series. All right. So here is still quadratics and inequalities. So we have inequalities there. And as I continue down, I'm going into functions here. Well, that was, so we're gonna skip over the functions. We'll go into indices and logs. So this is indices and logs. We can come back to all of these eventually. And then we're coming up to series. So sequence and series appear to start right here at number 17. All right. So I'm going to zoom up the screen, and what I will attempt to do is do the question on the paper here itself, but it needs be I break on another page to do it. All right. So the first question, sequence and series, is number 17 right here. But you can see that clearly, right? So I want to make sure. But you can see that question clearly. Give me some feedback, please. But you can see that question clearly.
Yes, sir.
Yes, sir.
So a lot of these questions, you might be you'll find that you might be familiar with them, right? Because there are so many and no more ways available to set a question, believe me. All right, it says in a geometric progression, so this is a GP, each of whose terms are positive, so this is very important. Terms are all positive. The fifth term is 45. The fifth term is AR to the fourth power. So I'm going to write AR to the fourth power is 45. And the seventh term is 5. The seventh term is 5. And we want to tell them the sixth term. The sixth term would be the one in the middle between them, right? But that is the fifth term. No, this is the fifth term. And the seventh term. The seventh term is AR to the sixth power. That is equal to 5. So you're trying to find the sixth term. And the sixth term is AR to the fifth power. AR to the fifth power. Or if you find the R, you multiply this term by R to get the sixth term, because that's the fifth term. The fifth term times R gives you the sixth term. All right. So normally I usually say to students, when you're solving simultaneous equations that are derived from an GP, usually divide them. So I'm just going to divide these two. Divide them. All right. And I'm going to divide, let's call this one 1 and call this one 2. I'm going to do 2 divided by 1. I'm trying to find the R. So it's this divided by this. This is my R squared. I'm going to get R squared. When I divide this side by this side, I'm getting R squared. R squared equals, I'm getting 5 over 45. I'm getting 5 over 45, which reduces to 1 over 9. So r squared is 1 over 9. Remember that I said the r is positive. So the r squared is 1 over 9. Then we square root this. The r is a third. R is a third. And then the fifth term, the sixth term is the fifth term times 5 times the r, sorry. The fifth term times r. So all we have to do is multiply. So I can put it here in a box. So the fifth term, the sixth term, sorry, is equal to the fifth times the radius times the common ratio. So it is 45 multiplied by the third, which gives us 15. That is 15. So the answer is this one. But I go to that. That's not the only way to do it, but that's a good enough way. But okay with that?
Yes, sir.
All right, next one. This next one says the common ratio of the geometry series, this series. Now remember, the common ratio is a term divided by the preceding term. Right? That's a way to find the common ratio. A term divided by the preceding term. So we can do this term divided by this term. We divide them. The 12 divided by the 8. Divide them. So the common ratio will be 12 divided by 8. That reduces to divide numerator and denominator by 4. We get 3 over 2. That's a common ratio, 3 over 2. So the answer is right here. So remember, a term divided by its preceding term is a common ratio. And you can check it if you want, because if you multiply this now by the 2/3, just check it, 12 times 3 over 2, the 2/3, 3 over 2. That's going to give me 80. Right? Because 2 into this and that was 6 times, 6 3 is 80. I'm going to get 8. So that's going to give me the next term. So this is just like a little quick check. Right? We don't need that. But that is the answer. Remember, term divided. So if you wanted, you could have done the 18 divided by 12 as well. So the common ratio is a term divided by its preceding term. If there's an arithmetic progression, a common difference is that term subtract the preceding term. Any term subtract the preceding term gives it a common difference when you have the sequence. All right, next question. 17a, 17b. Now, this is a sequence question. It's a sequence question. And UN just means the nth term. So just a way of expressing it. Some textbooks might write TN, but the term in a sequence. So it just UN is the nth term. So for example, if you want the fifth term, U5, you put 5 for the N right there. Simple as that. All right. Now this question wants a 10th term. So you want the 10th term. Simply means that the N equals 10. This simply means that the N is equal to 10 in this expression. Right? So we can go and write that U10, the 10th term, is 3 times half to the 10 minus 1. That's 3 times half to the 9th whole. That's what you're working with. So you can just use a calculator and do that. Right? Use a calculator, work it out. Let's see which one it is. I can do it in a head as well, because you're raising 2 to the 9th power, really. Right? So if I do 2 to the 9th power, 2 raised to the power 9. I'm getting 512. So the answer is 3 over 512. This one is the answer. Right? 3 over 512. Because this is the same as 2 to the 9th power. In other words, it works down to 3 over 2 to the 9th power. Right? So the 2 to the 9th power is 512. And then we have the 3 up here. Right? So the question is numeric. We use a calculator to work it out. 512. 2 to the 9th power. 2 to the 9th power. All right, that is that. All right, the next question here. It said some of the odd numbers between 10 and 50. Some of the odd numbers between 10 and 50. Now, this is going to be This is gonna be an arithmetic progression. If you list out the term that says between, and you want the odd numbers between. So starting at 11, then 13. Some of them you want. It says 11 plus 13 plus 15. Again, all the way up to 49. I want it between odd numbers. They're going all the way up to 49. So the question is, how many terms are there? For you to find the sum, the formula for the sum is the sum to n terms. A quick formula is n over 2 into a plus l. A plus l. When you know the first term and the last term, you can use that formula. Otherwise, it's n over 2 into 2a plus n minus 1d. For the a plus n minus 1d, that is actually a L, right? So that's how we can use this formula instead when you know the first term and the last term. And in this case, we do. What we don't know is the n. We don't know the last term. So we can use the term formula to find the number of terms. Right? What we know is that the last term is 49, right? So what's a term formula? Term formula is a plus n minus 1b. So 49 is the term when you have the number of terms in the sequence. So 49 is equal to 11 plus n minus 1. And in this case, the common difference is clearly 2. Common difference is clearly 2 because you're adding 2 to go from value to value. The difference between odd numbers are even. The difference between odd numbers is 2. So we're multiplying here by 2. What will be the n? The n will be equal to 49 minus 11 divided by 2 plus 1. That will be the common difference. The n, the number of terms that we need to put here in the formula. Right? That will be that value. So again, we can use a calculator. There's 49 minus 11 over 2, and then you're adding 1. There's 20 values. 20. So this then becomes equal to 20 over 2 into 11 plus 49. 20 over 2, 11 plus 49. 20 over 2 is 10. 20 over 2. If I write that, it will be 10 bracket, and it will be 11 plus 49. 600. So that's 600 right there. Now, if you can work these things in your head, no problem. These calculations quick and fast. But I'm just showing you how you would use a calculator. Right? So that is that. But okay with that? But okay?
Yes, sir.
Yes, sir.
All right, next question says, which of the following is not an arithmetic series, an arithmetic sequence? So it's the one that does not have a common difference. All right, the one that does not have a common difference, which is not an AP. In other words, if it is not an AP, we are saying there is no D, no common difference. So you're going to look at them and see which one are you trying to find a common difference in each one. The one that does not have a common difference is not an AP. All right, so let's list out what the common difference is for each one, if there exists a common difference. Now, this one, I can clearly see that this one, common difference is 4. Keep adding 4 plus 4 plus 4. So that one is pretty obvious. So the common difference for this one is 4. For this one, you can look at the common difference again. I am subtracting 2, and then subtracting 2, and then subtracting 2. I'm doing the easy ones first. So this one, the common difference is negative 2. Hold on a second. Hello? Is negative 2 for that one. All right, so it's between this one and this one. Which one it look like to you? Which one do you think? Which one do you think? Which one do you think it does not have a common difference on site?
Sir, A. Sir, A.
A. Tell me the common difference for this one then.
Sir, 6.
Common difference is not 6. Common difference is -6. Right? Keep subtracting 6. Be careful. So this one, the common difference is -6. So this one does not have a common difference. No D. So that's why this one is the answer. All right. And if similarly, they could ask you a question to show that, to find which one is not a GP. They could ask a similar question. They could say, which of the following sequence is not a GP? So in this case, in that case, you look for the one that does not have a common ratio. All right. And how you find a common ratio again? It's a term divided by the preceding term. So if there's no common ratio, then you don't have a GP. All right. Suppose they said to tell you if I hold on a second. Hello? Yes, what's up? Quick and fast. I'm in a class. So quickly. All right. Yeah, man, I'm here and Tavi is here too, so but I'm in a class. They can check me upstairs. All right. Yeah. All right, cool. Sorry about that, guys. All right. So this one now says first 4 terms in a okay. So I was asking a question. Suppose I say suppose I give you a set of GP, right? And I say which one of them has a sum to infinity? Which one of them has a sum to infinity? The one that has a sum to infinity is the one where the common ratio is a fraction, a positive or a negative fraction. Common ratio would have to be less than 1 or greater than -1. Right? This is the one that would have they say it is convergent. It has a sum to infinity. So they could give you a question where they ask you, which of the following GP has a sum to infinity? You're looking for the one where the common ratio is a positive or a negative value in terms of value less than 1. So it works out to a decimal value with, like, for example, -0.65 or -0.6 or even +0.7. 0 point something must be 0 point something. The common ratio must be 0 point something for it to have a sum to infinity, whether it be negative or positive. All right. So let's remember that. They could ask a question like that. All right. This one says the first 4 terms in a convergent geometric series are given as these. And they're asking us for the sum to infinity. So the formula for the sum to infinity is simply A over 1 minus the common ratio. This is clearly the A. And the common ratio is clearly 200 divided by 500. So we could write that out. The common ratio is 200 over 500. So the R is 200 over 500, which is 2/5. So it's a term divided by the preceding term. And the A is clearly 500. So this formula will become equal to 500 divided by 1 minus 2/5. Again, you can type this in the calculator, you can just work it out. Right? Work this out quickly, I'll multiply here by 5 and up here by 5. Right? But as I said, we can use a calculator. Hope you have one of those calculators where you can type in the information as it appears. So it's 500 over 1 minus 2/5. Like that. So we see that as a fraction, you have a calculator can give it to you as a fraction as well. So here it is. It's 2,500 over 3. But you could also just calculate it. All right, 2,500 over 3. So that becomes the answer right here. 2,500 over 3. Easy as that. All right. Next question here. So this one is another series, and they ask us to find what it converges to. Remember, it's a summing up. So again, you want to find the first term and the common ratio. And it converges to a sum. The sum that it converges to is a sum to infinity. Converges to the sum to infinity again is A over 1 minus R. So that's a similar question. Clearly from here, the A is -2. A equals -2. And the R equals a term divided by the preceding term. So it's this 4/3 divided by this. You could also do it another way. You could also say, what do I multiply this by to get this? With the negative, not the negative. What do I multiply this by to get this? The values are obvious. You multiply the 4 by a -2 to get the -8, so it's -2, and I multiply the 3 by 3 to get 9. So this is 3 by 3. So this is the common ratio. So you can also look at it, and even if you use the first value, this to this, what do I multiply that by to get this? This first value is same as -2/1. So I would multiply this -2 by -2 to get this 4. I multiply this 1 by 3 to get this 3. So the common ratio is -2/3. But if you want to do it theoretical way, it's a term divided by the preceding term. So it will be 4/3 divided by -2. It's going to work out to be -2/3. -2/3. And you just drop those values on this. Drop those values on that. So it becomes the -2, which is A, over 1 minus the -2/3. This minus becomes a plus. So if I'm putting it in the calculator again, then it would be -2 over -2, same thing, over 1 minus can become a plus 2/3. Right? I'm getting -1.2, which is -6/5 right here. -6/5. The answer is this one. That is it. So it equals -6/5. So this question is very similar to the one that we did a while. Right? This one here. This one says the sum of the first n terms of a GP, geometric series, is given as this. Now, this is the sum of the first n terms. And now, what I want you to remember, what I want you to notice, remember about when they give you the sum. The first term is when n equals 1. First term is when n equals 1. First term. So S1 is the A. A is S1 when n equals 1. Right? All right. It says, for this series, I want this guy to tell them which of the following statements is correct. So they give us three statements, which of them is correct. Right? So the first thing they tell us is that the common ratio is 4. Now, for you to get the common ratio, you need to know what the first term is. Since this is an expression for the sum, you can get the sum of the first term is the A, and the sum of the first term and the second term is when n equals 2. So we can set it like this, right? So working out the first term is when n equals 1, you know. So let's write it here. I just want some space. So A is S1, which is equal to 4 to the 1 minus 1, which is equal to 3. That's the first term. Now, when n equals 2, this is when n equals 1. You know? This is when n equals 1. Now, when n equals 2 is the sum of the first two terms of the GP. But the first two terms of the GP would be A plus AR. That's the sum of the first two terms of the GP. You know? A plus AR. And it is equal to S2. When n equals 2. And when n equals 2, it becomes 4 squared minus 1. 4 squared minus 1, that is 15. This is when n equals 2. Let me see if I can get some space just to put n equals 2. So this is when n equals 2. N equals 2. So we know that the A is 3, so we can drop the 3 on here and here. So this equation is telling us that 3 plus 3R is equal to 15. And from this, if we solve for R, you can subtract 3 first and get 12 and then divide by 3. You're going to get the R equals 4. So you know that the R is 4 and the A is 3. So R equals 4 and A is 3. So they said the common ratio is 4. So we know that this is correct. So the first three terms are 3, 15, and 63. First three terms. Is this correct? No, because the common ratio is 3. Then the series is 3 plus 12. I put the computers common. 3, then 3 times 4 is 12. Then 12 times 4 is 48. And so on. That would be the series, right? So this is not correct. But R is 4. And then the next question is this correct? Is that correct? No, this is a sum to 2n. So when this becomes 2n, this also must become 2n. So we can check it right here, see if it is correct. So if we use this formula, then S2n would be 4 to the 2n minus 1. We see this 4 to the 2n right here. This 4 is same as 2 squared, you know? So this can be written as 2 squared to the 2n. 2 squared to the 2n. Let's write that better. Minus 1. And then this times this, using the laws of indices, becomes 2 to the 4n minus 1. So therefore, this is correct as well. This is also correct. So let me do the ticking on the other side. I want to tick this one is correct. This one is not correct. This one is correct. So 1 and 3. 1 and 3 is correct. 2 is not correct. And look here, based on these answers, could have, based on the fact that 2 was not correct from here. That's why I say it's so important to look at the answers. You know? But eliminated this one and eliminated that one and eliminated that one because the 2 is not correct. Right? So once we establish that the 2 was not correct a while ago, right here, but I eliminated these 3. So 2 there, 2 here, and 2 here. So those 3 not correct. So that had to be that B was correct. So we did not have to do test the last thing, actually. But these are the answers though. So based on these, we could have known the answer from the get-go. All right, so we said 1 and 3. It's true. But okay with that? Very good. Students?
Yes, sir.
Okay?
Yes, sir.
Next question. It says for an AP, this is an AP now. What is the nth term? So basically I want to find the D. That's what this is about now, you know, finding the D. So remember, the D is a term minus the preceding term. And I don't have to work with these negative values. You know. I can just come right up here and use those two. The D is equal to 8 minus 3. I don't have to complicate it, which is equal to 5. Once you know the D and the A is clearly 12, negative 12, I mean, A is negative 12. The nth term, we call it Tn. Formula for it is A plus n minus 1 times D. That's the formula for the nth term. A plus n minus 1D. All right, so the A is negative 12. The A is negative 12 plus n minus 1 times 5. Because the D is 5. And let's work this out now. So this is going to give me negative 5. 5 times negative 1 is negative 5. The negative 5 and negative 7, the negative 12 is negative 17. And then the 5 times n is 5n. So it becomes 5n minus 17, which is the first one. I'll give you a 20. I got a spring machine, right? Good year, some Theo. All right. Okay, students, sorry about that. I'm at work, I'm multitasking, all right? So, yeah, I'm not gonna get a lot of disturbance, but so sometimes. But okay with this, right? But all right with this? But okay?
Yes, sir.
All right. So number 20. This one says, a long distance runner runs the first kilometer of a race in 3 minutes, 45 seconds. Now, this 45 seconds, I've realized that's 3/4. Right? 3/4. So that's the first, he runs it in 3.75 minutes. Because 45 seconds is 3/4 of an hour. But finds that his speed drops steadily so that each kilometer takes him 12 seconds more than the preceding. So basically, he's running them at 12 seconds more. So the next term is going to add 12 seconds. So basically, that's a common difference. So the common difference is 12 seconds. So this is the first term, and the common difference is 12. We're talking about since you're increasing the time by the same amount for each kilometer, it becomes an arithmetic progression. And this is a common difference, the amount that you're increasing the time by for every kilometer. This is how much it takes. It will be the first kilometer, 3.75. 3.75, about 3 minutes, 45 seconds, 3.75. I'm going to work with one figure. All right. It says the time taken to cover 12 kilometers. That's a sum, you have to decide what they're asking for. What is the time taken to cover 12 kilometers? They didn't ask you for the time to cover the 12th kilometer. Now it's going to be a different thing. That will be the T12. They ask for the 12th kilometer. This is asking you for the total time. The time taken to cover the first 12 kilometers. That's a sum to 12 terms. This is time taken for to cover the first kilometer, and this is the common difference. They want the sum to 12 terms. So they want the sum to 12 terms, which is 12 over 2 into 2a, 2 times 3.75 plus n minus 1d. Now the n minus 1 is going to be 11. Shift this over a bit. Right? So plus n minus 1d. The n minus 1 is going to be 11 because the n is 12. The d is 12 and the n is also 12. Right? 12 kilometers. And the d is 12 seconds. Right? So the n minus 1 becomes 11 times the d, which is 12. And basically that's what they're working on. That's what they're working out. And you put that in the calculator and see which of these answers matches it, right? So you're gonna get everything in minutes. Well, let's give it out in minutes. We're gonna get everything in seconds here. To get it in minutes, we're gonna divide by 60, because this is in seconds, right? No, this is in minutes, right? This is in minutes. Oh, it took 12 seconds more, so it's not 12 anymore. We're working in minutes. All right, so it's one of two things. Are we gonna work in seconds straight, or we're gonna work in minutes? So maybe based on the fact that D is in seconds, right? What we can do is work out everything in seconds. So the D is not 12. The D is actually 12 over 60. But I think it's easier for us to work in seconds. So let me change this. And this 3 minutes is 3 times 60. So this becomes, working in seconds, this becomes equal to that figure, 3 times 60 seconds plus 45. You have to work either in seconds or minutes. So my mistake there. So it's 180 plus 45. So the first time that he took was working in seconds is 200. So the A equals 225 seconds. Let's put that's 225 seconds. Let's write seconds here. Seconds. They're working in seconds. So we'll get the time. We're gonna get it in seconds. So let me change this now. So this becomes 225. So it's 2A. A becomes 225. 225. So that's 2A plus n minus 1D. 2A plus n minus 1D. All right. So this is gonna give us in seconds. So that was a mistake. You cannot work in minutes and seconds at the same time. We decide. So working in seconds. So this becomes a 225, which is a A. 225 seconds, right? And the common difference is 12 seconds, and the number of kilometers, the number of terms is 12. So that is what we're working on. We're going to get it in seconds. After we get it in seconds, because this has minutes, we're going to divide by 60 to get it in minutes. So let's work it over now. So out here, so is 6. So we want to do 6. I want to put 6 bracket. We're going to put 2 times 225, which is really 450. And then we're going to add 11 times 12. I want to get that. So I want to get 3492 seconds. And divide that now by 60. And you get 58.2 minutes, which must be the first answer. Right here. Better go with this. Better okay with that? Better good?
Yes, sir.
So let's see again. All right, so this one now is like a serious question. I get a question like this. It's just a sum to 3 terms. So the sum of 1 over k from k equals 1 to k equals 3. So that's a very easy question. It's numeric. The first term is when k equals 1. So you're basically adding up. And remember, this means the sum of the values. So you have 1 over 1 plus the second term is when k equals 2, 1 over 2, plus the third term is when k equals 3, 1 over 3. That's what you're adding up. So don't complicate it. Just work that out. Right? So it's 1 plus a half, 1 plus a half, plus a third. Right? Not minus, plus. And you work that out. And the answer is 11 over 6. There, 11 over 6 right here. So this is the answer. This is a sum, and it's a small number of values. There's a sum to 3 values. Just list them out and add them up. Easy. It's numeric. All right, only 3 values to add right there. That finishes that one. This one now. All right, so this one now is gonna be an AP again. So the sum of the first n terms is given as this. So what you can do, you can start out by listing what the terms are. The first couple of terms, see what the common difference. Common difference actually going to be minus 3. Okay, every time you keep subtracting another 3. But if you list it out, you're going to see that the first term is when r equals 1. When r equals 1 right here, this becomes 5 minus 3, which is 2. That's the first term when r equals 1. So yeah, r equals 1. So when now r equals 1, r equals 2, r equals 2. Listen to this. R equals 1, then r equals 2, then r equals 3, and so on. So I'm going to put the value when r equals 1. So when r equals 1, you get 5 minus 3, which is equal to 2. So the first value is 2. Plus, when r equals 2, you're going to get 5 minus 6. 5 minus 3 times 2 is 6, which is negative 1. So the second term is negative 1. Right? And then the third term is when r equals 3. So when r equals 3, you're going to get 5 minus 3 times 3. 5 minus 9, that's negative 4. So you're going to get plus and negative 4. So these are your values. Right? These are your terms. So based on that, it's an arithmetic progression. Right? It becomes an AP. Let me write that out in purple. It is an AP with a first term of 2, a common difference of negative 3. You can see that it keeps subtracting 3. You could see that right here. It keeps subtracting 3. So the common difference is negative 3. And the number of terms is 10. And sum the 10 terms. So n equals 10. I'm trying to find that sum. So the sum to 10 terms, I have to write the formula again. Sum to 10 term becomes 10 over 2, n over 2, into 2a, 2 times 2, plus n minus 1. N minus 1 is 9. 10 minus 1 is 9. Times d, n minus 1 d. The d is negative 3. That's what you're working on. Right? So again, you drop that in the calculator. This out here says a 5. You get 5 bracket. This right here says a 4. We're gonna put 4 there. And this right here says negative 27. 9 times 3 is 27 minus 27. And that gives us negative 115. So this is the answer right here. Negative 115. But okay? But okay with that?
Yeah.
But okay? All right, good. This next one, right? This one is gonna be again, see those 5 terms and see you could literally just list out the 5 terms and thing, instead of going into no formula thing, it's just 5 terms. Just list them out and add them up, right? So put in 1 here and 1 here first, right? So when I'm gonna list them out. I'm gonna put in R equals 1. R equals 1. Let's list them out quick and fast. We don't have to make it complicated. R equals 1. R equals 2. R equals 3. R equals 4. Right? And R equals 5. Just all the 5 values. What is the value when R equals 1? Let's put it here. I'm adding them up, right? The value when R equals 1, this becomes a negative 1, and this becomes a 3 to the 2. And that's what it becomes. It becomes negative 1 times 3 squared. So it becomes a negative 9 when R equals 1. When R equals 2, I get negative 1 squared times 3 cubed. 3 cubed. So this becomes a positive 27. This negative 1 squared is positive, so and the 3 cubed is 27. The positive 27. When R equals 3, I get negative 1 cubed. I'm going to make this negative again. Times 3 to the 4th power. So I keep multiplying by 3. So 3 to the 4th power is 81. So I get 81. When R equals 4, I get negative 1 to the 4th power. I'm going to come out positive again. Times 3 to the 5th power. So I must see the trend now. And so I multiply 81 by 3 to get the next value. 81 times 3. But negative. Sorry about that. This part. All right, so I'm getting negative 243. Negative 243. And then when R equals 5, we're gonna get minus 1 to the 5th power times 3 to the 6th power. And that works out. We're gonna multiply this by another 3 again. So we're gonna get the positive though, 729. I add up all of them. So 729. So we can say it's 729 minus 243 plus 81. I'm mistaken now. This is supposed to be negative. The alternative. This is negative 81. Minus 8. No, hold on. This one is positive. All right. So the second one is positive. The third one is negative. It's negative 81. This one is positive. See, this is us to the 4th power. So this one is positive, and the last one is negative. My mistake. So this one is positive, and this one is negative. Right? The alternate. So negative, positive, negative, positive, negative. All right, let's go again. So become negative 9 plus 27 minus 81 plus 243 minus 729. Negative 549. And question is numeric, just work it numeric. And it's all the 5 values are added. Easy as that. If you do it, it will become a GP. It could become a GP. I want the sum of the GP. 5 terms. Right? Common ratio will be negative 3. You could do it that way again by writing on the first 2 values. Realize it's the GP, the common ratio of negative 3. I want to sum the 5 terms. You could do that. But this is numeric, is only 5 values. You can just add them up like that, quick and fast. And basically, that finishes the series part of the paper. That finishes the series part of the paper. Anybody have any preference that they want to do? We're gonna do for sure We're going to do vectors and trigonometry later on. I'm not going to do that up front. Anybody have any topic of preference that I want to do apart from those two? We're going to do those later. Vectors and trigs. We're going to do later on. Anybody have any topic? Just shout it out that they want me to do. No? Anybody? All right. I'm not getting any preference, so let me jump to the beginning then. Anybody there with me still? Just want to make sure.
Yes, sir.
All right. And do you have any preference of topic? First who answer, do you have any preference of topic?
No, sir.
All right, cool. All right. So let us just go to the beginning then and work our way down. All right. So let's go over here. All right. So these are polynomials, factor remainder theorem questions. All right. All right. So this question says, this is a factor of which of these? So in other words, we are searching for the one where f of 2 is equal to 0. We're calling these f's. So we're searching for the one where f of 2 is equal to 0. And one for which f of 2 is equal to 0 is a factor. So we have to try the values. So like we're substituting the 2, because if this is a factor, then f of 2 equals 0. All right. So I want to plug the 2 in this first, and it will become 4 times 2 to the 4th power minus 2 times 2 squared minus 56. That's what we'll get there. This penalty is small already. I wrote that out with the calculator. So it will be 4 times 2 raised to the power 4 minus, but it's going to be 8 for sure. Minus 8. And then minus 56. And voila, we get the first one. This is equal to 0. So we are blessed. We don't have to test another one. That says A. All right. So that is good. When the first one is answer, you have to use a trial and error method. And that is that. All right, next one. It says this function can be expressed in this. Now, this is when it is factorized. So these are 2 factors that we know. In fact, we know 3 factors. So since we know 3 factors, right, we can use the factor theorem. For example, since this is a factor, x minus 2 is a factor, this means that f of minus 2 is equal to 0. This factor, x minus 3 is a factor. It means that f of 3 is equal to 0. And this factor would mean f of negative a half. Right? Because if you make the t equals 0, the x is going to be negative a half. So this one would mean that f of negative a half is equal to 0. So Eric, whichever one of these is easier for you, and put that equals 0. So I would use, for example, the 3. I could use the negative 2 inside there. So if I'm using the negative 2, f of negative 2, let's say I'm using the f of negative 2, put it equals 0. Then it will be 2 times negative 2 cubed that better, minus negative 2 squared, that's from here, plus the negative 2 times 8 is going to give me negative 2h. So let me just write minus 2h, minus 2h, and then minus 6 equals 0. And I'm solving for h. So I can carry this minus 2h over this side and get 2h. 2h equals an other part of these, right? Other part of these. And again, we can use a calculator and do it. But this would be negative 8. Negative 8 times 2 is negative 16. So it would be negative 16 minus this would be a 4. And then this would be a negative 6. And then this would be negative 10 and negative, that would be negative 26. So you would have 2h equal negative 26. And so the h is negative 30. So the h is negative 30. That is the big answer. You could also use the f of 3 equals 0, whichever one. But I chose the f of negative. I'm not going to work with a half, clearly. F of negative half. Could I use f of 3 again equals 0. So whichever one you decide to use, you're going to get the same answer. That is it. And that's not the only way to do it. Because another way to do it would be to expand this out and equate the coefficients. Right? But I think this is the easier way. Right? Whether you put the f of negative 2 equals 0 or the f of 3 equals 0. That's the easier way to do it. Right? So the h equals negative 13. All right, next one. This one says, given that x plus 2 is a factor, it's a similar thing. If x plus 2 is a factor, then this is a factor, means that f of negative 2 is equal to 0. And that's what you're solving. F of negative 2 equals 0. So f of negative 2 equals 0, it will be 2 times negative 2 squared, cube, sorry. I'm not writing this 3 properly. Minus 3 times negative 2 squared minus 5 times negative 2 plus p, and that is equal to 0. Well, this again is going to be negative 16 for sure. Negative 16. And this is a positive 4 times a negative 3 gives me negative 12. And this becomes a positive 10. And that is equal to p. Whatever this works out to, not equal p, not equal p, it equal minus p. So plus p equals 0, equal minus p. So whatever this is, I make it negative, and that's the answer. So this is negative 28 plus 10, that's negative 18. Right? So it's negative 18 plus p equals 0. So clearly the p equals 18. So p equals 18 right here. What is that? All right. Next one is first to factorize this completely. This factorize completely as so. All right, so we can look and see which one would be consistent with the values. Let me see if we can use an observation method and do it. Right? So what I know is that the first value here is a product of the first 3 values. And let's see if that is true for all the cases. Let's see. Yes. So for all the cases, x times 2 given out the first term. And then the last value here is a product of all the second values. This times this times this. Let's see if it is consistent. So this time, this is giving me a positive 6. So this is not correct. So focus now is on the third value. Let's see if that will help us. So this negative 6 is a product of the second value. This time, this. So those 3 would give me positive 6 if I multiply them, which is not correct. And then this times this again will give me a positive 6. This will give me a positive 6. Again, that is not correct. Right? And then this times this again gonna give me a positive 6. I need a negative 6. Those 3 giving me a positive 6. So that is not correct. So it must be the last one that is correct. And this giving me a negative 6, which is correct. So you see, you don't have to actually expand it out, guys, to know. This is the answer. So remember, the product of the first 3 values is the first term. Product of the second values is the last term. And so we use a process of elimination here. We're looking for the one where the product of the last 3 values matching the last term. But I understand that? Everybody good?
Yes, sir.
All right, beautiful. This one says, when this thing is divided by 2x minus 1, what is the remainder? The remainder is f of a half. If I call this f of x, the remainder is f of a half. All right? Because remember, when this is your divisor, it's like you put the divisor equals 0 to find your a. All right? So it will be the x equals a half. So you're searching for f of a half. All right? So the remainder is f of a half. So all we have to do is put the half in here and see what we get. So it becomes 2 times a half cubed plus 3 times a half squared minus 2 times a half plus 3. Now this is 1 over 8 times 2 becomes a quarter plus this is a quarter times 3 is 3 over 4. And then this now is 1. And 1 is the same as 1 is the same as 4 over 4. So putting everything over 4. And then this 3 is the same as 12 over 4. And you're just adding up the values on the numerator there. So this is 16 and 4 make 20. So it becomes 20 over 4. 20 over 4, but I'm not seeing that answer. Did I make a mistake? Oh, a mistake with the negative. A mistake with the negative somewhere. Which is right here. It's supposed to be minus. Right here. It's supposed to be minus 4 over 4. Minus 1 is minus 4 over 4. Let's go again. So it becomes boom, bang, boom, bang. Well, this cancels this. It becomes 12 over 4. Because this is 4 and that is minus 4. So all of this is gone. So we'll just get that 12 over 4. In other words, we'll just get this short here. So the answer is 3. So this equals plus 12 over 4, which is 3. The answer is this. But all right? Are you okay with that?
Yes, sir.
All right, so I could just drop this in the calculator one time as well, and you get the 3. All right, but some of these small numbers can be worked out easily, so we don't need the calculator in all cases for these small numbers. But sometimes I find the calculator takes more time actually. If you're comfortable with the calculator, no problem. And as I was saying, when the questions are numeric, use a calculator. All right, move quickly. Just make sure you enter the correct thing. When this polynomial is divided by x minus 1, the remainder is same thing again, f of 1. F of 1. When it divides at x minus 1, the remainder is f of 1. So just plug in 1 in there. And the f of 1 or p of 1. Since I call it p, we can say p of 1. We call it p. So we can call it p of 1. And p of 1 is equal to. So since it's just 1, then all these numeric values come back. So this is going to become a 2. It's going to become a 1 square, which is 1. It's going to become a minus 13 plus minus 13 and plus a 6. Plus 6. So basically this is 9 minus 13, which is negative 4. The answer is negative 4. All right, 9 minus 13 is negative 4. What is that? Next one. All right, next one is this. It says the linear factor of this is what? So it's a 1 that produces 0. All right, the 1 that produces 0. The one for which f of a is equal to 0. So basically then, what is the a from this? A from this is 1. What's the a from that? This is 2. A from this is negative 2. The a from this is 4. All right, so let me write them out. So from this one, so we're looking for this. We're looking for f of a equals 0 and put it above here. All right, and saying for this one, the a is equal to 1, the a is equal to 2, the a is equal to negative 2, and the a is equal to 4. So we're trying 1 in there first, f of 1. So f of 1 would simply be 1 minus 3 again. This will be minus 3. This will be minus 3 again. And then minus 4. So this one is not equal to 0. Don't have to work out. Not equal to 0. So it looks to me like it's going to be one of the positive values. Because all these negatives, you have to balance them out. So I'm going to try this one. next, right? Because this 2 is gonna make me keep subtracting values here. Right? So I'm not going to try the second one. I'm going to try this one. Try the f of negative 2 and see. And if f of negative 2 is going to become negative 8 minus negative 8. When I square this, I'm going to get positive 4 times negative 3 is negative 12. So it's minus 12. Then it's going to become a positive 6. It's not going to work either. Positive 6 and then minus 4. All right, so these negatives too much, so it's not equal to 0 either. Wow. Well, let's try the last one then, no? So f of 4. So this is gonna give me f of negative 4. F of 4, f of 4. So it has to be one with a positive. A positive. Should I really try the second one then? Anyway, let's try the second one. Let's try the second one, f of 2. F of 2. Maybe there's an easier way to do this, but no worries. 2 cubed is 8 minus, this becomes 4 times 3 is 12, but that's a negative 12. And this becomes a negative 6, and then a minus 4. It's not working out either. So you see that not equal to 0 either. That must be the last one then. Let's see. F of 4. So I'm going to get 4 cubed right there. 4 cubed is 64. That is 4, 16 times 4 is 64. Then this is 4, 16. 16 times 3 is 48. So it's going to be 48. I'm going to minus 48. And then I'm going to put minus 12 right here. Minus 12. And then minus 4 more. That one works. 64 minus 48 minus 12 and minus 4. Wow. Last one. The last one. Last one. So I'm going to see if we can glean some from this one. So the last one. So we'll have a try all of them. So because these are all negative, right? Has to be one of the positive values. Because you want to have a large positive value and you're subtracting all of these from down the line. Generally speaking, is a factor of the last value as well, right? But the problem is that the 2s are also factors of that. So I don't know. This trial and error, if you look at the size of the number, that the 4 cube here is going to be very large relative to the 2 cube and the negative 2 cube, right? And then subtracting these. But that is the last. That is the answer. The last one. All right, that is the answer. Next one. So given that f of x is equal to this is less than or equal to k. This is not a, this is a function. K equal, let me say, given that f of x equals that is less than or equal to k. Okay, so this actually is a quadratic, Given that f of x is less than or equal to k, it means that k is a maximum value. That's what it means. K is a maximum. If it is less than or equal to k, it means that this k is a maximum value. So basically asking you to find the maximum value. Is the maximum value. You can find the maximum value by completing the square, or you can find it by using the formula. Right? Using the formula. Formula for the formula. So when you write the quadratic, so this is a quadratic, right? The quadratic expression or quadratic function, that is. So it is a into x plus h squared plus k. K is the maximum value. For the a negative, a is negative 2. Now the h is b over 2a using a formula method, right? And the k is 4ac minus b squared divided by 4a. If you want to use a formula without having to to go through the process of completing the square. So this is good to know. So when this is our plus right here, it's very important. It's b over a. B over 2a is when you have a plus h, not a minus h. Now, because this becomes a minus h, then this becomes minus b over 2a. When it's a plus h, the h is b over 2a. All right. Another thing to know is that your maximum point, if you want coordinates, or minimum point, minimum maximum point, in this case, is a max. Right? When using this h formula and this k formula, it becomes minus hk using this method. That becomes the coordinates of the maximum point. So if you're using the formula method, the question is really asking us for k. All right, so you can go back for the red. And so the k equals 4 times a, and the a is the coefficient of the x squared. Remember, coefficient of the x squared, which is negative 2. And the c, which is a constant value, 6. Minus the b. The b is negative 1. There's no number in front of the x, there's a 1 there. It's negative 1. So the b is negative 1. So you're squaring negative 1. So this stays a minus number, but you're only squaring the negative 1. Divided by 4a. 4 times a. A again is negative 2. That's what you're working on. You can drop that in the calculator. You can also work it out. This becomes negative 48. Right? Negative 48. Minus, this becomes a negative 1 over, this is a negative 8. So negative 49 over negative 8, which becomes 49 over 8. So the key is 49 over 8. That's the maximum value. So the answer is this one. That's a good enough way to do it using a formula method. Otherwise, you could complete the square, right? We're going to see some other questions asking us to complete the square, but that is it. All right, everybody okay with that?
Yes, sir.
All right. So remember, you could use a formula method to complete the square, especially on the multiple choice. You don't have to show the work. So the h right here is b over 2a. The k is 4ac minus b squared over 4a. Right? And remember, the maximum or minimum point is minus hk. Remember, the a is the coefficient of the x squared. So for this one, let me write it out up here. For this one, the a is negative 2. Let me shift it over. The a is negative 2. The b is negative 1. And the c is 6 for this one. All right, the c is 6. The number in front of the x squared is the a, which is negative 2. The number in front of the x is the b, negative 1. Don't put x in on negative 1. There's no 1 there, but you have to put negative 1. Like you have a negative 1x. And the c is a constant value in the expression, which is a 6. That's the a and a, b, and c that you can use in this formula to complete the square. Right? And you complete the square in this format. The h is b over 2a, and k is 4ac minus b squared over 4a. You can remember them formula there? And this question can be done easily on a multiple choice because you don't need to show the process on a multiple choice. When you're doing the actual paper 2 now, you have to show the process. Then generally you use the formula method. You have to show the process. All right, so that is it. So the formula is good for multiple choice. Yeah. Formula is good for multiple choice. All right, so like we're in the quadratic section now. All right, so this one says, what is the quotient? What is the quotient? And the quotient is what ends up on top here when you do a long division. That's what the quotient is. So divided by x minus 2. So the quotient is up the top there. So like we start the division. So to do this, I'm just going to just start the division. So like I'm dividing with the x plus 2. And I'm dividing x cubed minus 7x squared plus 2x minus 1. And my quotient is what is up here. My quotient, underline it. My quotient is what I end up with up here at the top. Up there. My remainder is what ends up down here when I'm done, if there's any. And this is my divisor that I'm dividing by. And this inside here is my dividend that I'm dividing is my dividend. Right? But I want the quotient. So like I'm going to do the division. Right? So it's this divided by the x is x squared. Here. So you know, so it can't be none of these, right? Those two out of it. And by the time you reach the second value, you know, you see, minus 5x minus 9x. You don't have to finish it. By the time you reach the second value, you will know. Right? So it's x squared times these now, giving me x cubed plus 2x squared. And I'm subtracting these. Right? I'm subtracting everything. So the top line minus this line. So I see 9 already now, because this minus give me a negative 2x squared and a negative 2x squared and a negative 7x squared give me a negative 9x squared. So I know that I'm going to get a negative 9x up here now. So I know that that must be the answer. I don't have to work anymore, right? Because I will bring these two down and get the plus 2x minus 1. Because I know, go and divide this by this and get the negative 9x. I don't have to go any further. The answer must be this one. I don't have to go any further. I don't have to finish it. It's a multiple choice. I've eliminated these. Right? So the answer must be the last one. I don't have to work out the thing. All right, next one. The expression is equal to 1. This is a simple algebra. We want it to factorize. Right? We want us to factorize. And the first thing I notice the a comes first upon everything. I'm going to put these two together and factorize away the a. So if I rearrange it and write it as ab minus ac, then I put these two in the order b minus c, b to c. Because this have b to c. I'm going to write these two in that same order, b to c. And therefore, I'm going to write minus 3b plus 3c. Now factorize the a away from this and get the b minus c in the bracket. Right? B minus c. And I must get a b minus c in the bracket over here as well. All right? And then a negative 3 is factorized out of this. I'm going to put the negative 3 here. Right? So that's how we get the a minus 3 and b minus c. Right? So a minus c, a minus 3, b minus c. So that's the last one. But okay with that? That's just a straight factorization. Straight factorization. Straight factorization. Hold on a second. All right. This one now. We want us to write this as a single fraction. Which one is a single fraction? So I must observe the difference of two squares here. This is one part of the difference of two squares, that x plus 3. Right? So let me just erase this thing so I can show the work beside it. Let me just mark out this 2a right here. So I can show the work right beside it before I do it. So because this is already. All I need to multiply this by is by x minus 3 now. So for that product to become x squared minus 9 now. So I'm going to multiply, I want the two denominators to be the same. So I'm going to multiply this fraction by x minus 3 over x minus 3. Let's put it here. X minus 3 over x minus 3. This product now is really the same as this expression. So this product now is the same as x squared minus 9. So like I have x squared minus 9 over under here now. So all I need to do now is add the numerator. And this times this 1 makes this the numerator, x minus 3. Right? So it becomes equal to, this becomes equal to, if I add up the numerator, the 3 is eliminated. So I get x on the numerator over the denominator becomes x squared minus 9. So that is the answer, you know, which is A. The answer is A. But understand that? But understand that?
Yes, sir.
All right. That's easy look at algebra, right? But this was a part of one factor of x squared minus 9. So it's multiplied by x minus 3 to make the denominator become x squared minus 9 as this one is. And they add up the numerator values. So that's it. Simple algebra. All right. So this one is a quadratic now. Now, this one says which are the graphs best fits this? Right? Now, first thing you want to look at is that if I were to expand it out, I'm going to get a negative x squared. Right? You can actually expand it out if you want and get x minus x squared. But these are in the factor form, and so when you know the factors, you also know the roots. So this one giving me a root, this factor giving me a root of 0. X equals 0 is one root. And this factor, if I put it equals 0, giving me a root of x equals 1. So these are my two roots. And this is a root. And this also is a root. The roots are the values where the graph intersect the x-axis. Right? X values where the graph intersect the x-axis. And this negative x squared means that I have a frown. So we can sketch that I have a frown. So I'm looking up for a frown with these two roots, 0 and 1. I'm looking for a frown with 0 and 1 as my two roots, 2 points where it intersect the x-axis. As simple as that, you know, 0 and 1. So if I even draw the x-axis here, so and this is a sketch, right here must be 0 and right here must be 1. That's what I'm looking for, 0 and 1. Right? So which one of them match that? This don't match it because this root is negative 1. Right? This don't match it because it's a smile. Right? This one don't match it either because it's a smile. So 2 reasons why this one don't match it. Right? And this one don't match it because this root is negative 1. Second one is the one that matches it. Okay? You have the two roots, 0 and 1, and it frowns. So this is the answer. That's it. There's another one beside it, similar, but instead of a x minus 1 minus x here, you know, x into 2 plus x. When I expand this, I'm going to multiply the x times the positive. I'm going to get a positive x squared. So it's going to smile. If I were to expand it, it will be 2x plus x squared. So automatically, I know that I'm going to have a smile shape because the square term is positive. Let's talk about the roots again. When you know the two factors, you automatically know the roots. This root of x is gonna give me a root of x equal. This factor, sorry, of x is gonna give me a root of x equals 0. That's one root. And this factor of x minus of 2 plus x, if I put equals 0, I get x equals negative 2. So this factor is gonna give me a root of x equals negative 2. That's my second root. So I'm looking for now a smile with a negative 2 root and a 0 root. So I'm going to put them on this sketch. 0 root and a negative 2 root. That's what I want. Easy as that. So looking for a graph that matches that. Right? So which one? This don't match it because a positive 2 root it has. Want a negative 2 root. Smiles, you know. Smiles, you know, but have the wrong root. This one no match because a frown. We're looking for a smile. So even though it has its correct 2 roots, it's 0 and the negative 2. This one is not it because it frowns. We're looking for a smile. This one don't match it because it frowns. So that one don't match because it frowns. It must be the last one. See? It smiles and it have a 0 and the negative 2 roots. Right? So this question is very simple, guys. So you look for that smile or frown and look for the roots. Remember, if you know the factors, you know the roots. Right? Put the factor equals 0 and find the root. But okay with that? But
Yes,
okay?
sir.
Yes, sir.
All right, let's continue. This one now. This one says the number of visas V issued by the embassy annually is given as this, as a quadratic. So the number of visas issued is given in a quadratic function, right? And it says the least number of visas issued in X years. X is the number of years. So this is going to have a smile shape. So it's going to come down to a minimum. So what is that minimum? The same formula I gave you, right? We're asking for the minimum of a quadratic, which is the K, right? So if you write the quadratic in the form, write out again. We write the quadratic in the form A into X plus H squared plus K, right? The K is the minimum. So the minimum K is 4AC minus B squared divided by 4A. That's the easy way to do it on a multiple choice paper. Let's use a formula. You have to go through the process of completing a square. Just use a formula and get this. What is the A and the B and the C? Let's write them out. So from this, right, the A equals 7, the B is negative 42, and the C is 72. That's what they're working on. All right, the A is a coefficient of X squared, the B is a coefficient of X. Notice that I put the negative sign on it, and the C is a constant term. So you're finding the K using those values. So the K equals 4 times the A, which is 7, times the C, which is 72, minus the B, which is negative 42 squared. Don't be afraid to use a calculator now. Divided by 4A, 4 times 7. So let's drop that in the calculator and see what one it is. Let's go. We have to kill ourselves. Let's drop them in the calculator. Because you can use it. So why not use it? Looking for a fraction that has 4 times 7 times 72 minus, it's going to be 42 squared, just the same. And the negative 42 squared and positive 42 squared is the same. So it's 42 squared. And I put in that over 4 times 7. Get 9. Argument done. Answer is 9. You can fast, nice and easy. Very good. As I said, when you want to find maximum or minimum, this is a very good formula to know, guys. That formula right here. 4AC minus B squared over 4A. Find out 4AC minus B squared over 4A is a good formula for finding the maximum in the vertex form of the quadratic. All right, down here now. Give us this again. And you see, they want us to find the A and the K really. Right? And this is the quadratic. We do have to complete the square. Right? So the A is gonna be 1, you know. Can't be this, you know, because if you have X squared alone, then like you have 1X squared. So the A is 1. But what is the B? What is the H? So if we think of this, the same format, you know. Then if I write the formula down here, the H is B over 2A. Now the beauty about it, you know, is that all of these 4 values different. So anyone you find, you're done. All right, you don't have to work out the K. But these are 4 different H values to give you. So anyone you get is the answer. All right, so let's see. We know so this one out of it already. But the A can be negative 1. So let's work it out. Question is, what is the B? B is not 6, you know, it is negative 6. So maybe that is the only way somebody could give away the mark. You know? The B is negative 6. So I'm going to put negative 6 over 2 times A. The A is 1. And so that becomes negative 6 over 2, which is negative 3. So this has to be the one. But this is the answer. I don't have to work out the key. This is the correct answer. Right? If you were to work out the k, however, it will be 4ac minus b squared divided by 4a. Remember, it's not 2a. A lot of people make the mistake and put 2a on the year all the time, but it's 4a. So it will be 4 times the a value is 1 times c. The c value is 13. 13 minus b, which is a negative 6 squared, divided by 4 times a. The a is 1. The a is 1. Let me write those values up here for the a to be honest. If I underline this again, then I'm saying for that the a is equal to 1, the b is equal to negative 6, the c is equal to 13. And if you use the calculator and work this out, I'm sure you're going to get that 4. Let's see. Sure you're going to get that 4. So let's just clear this. Working this out. So it is a fraction. 4 times 1 times 13 minus 6 squared is 36, and you put in that over 4. So you get the 4. Right? So that proves it. It's correct. But that is that, guys. We have to work out everything. The multiple choice is a process of elimination. Right? So we don't need this part of it. This part equal 4, and we never need it. This part equal 4, but it's not needed. This part not needed. Not needed. All right, right. This was not needed. Never need to find this part. Because based on the fact that they gave us 4 different values for the h, we're done from right here. So, all right. All right. When I finish the quadratics, I'm going to take a break. All right. I'm going to take a break. I would love to finish this, all of this today. So we'll have to come back on it because people have other exams to do. All right. Look at this one now. So same thing again with this one now. If you want, you can go through the process if you like. But at the same time, you can just maybe just calculate the values. Right? You can just calculate the values, but you can go through the process if you like. Right? And start the process now. So I can say, okay, I'm gonna write it as, because I'm in the multiple choice exam, I don't need to show no working. I'm gonna write this as a into x plus h squared plus k. Right? The h is b over 2a. So the h is b over 2a. Well, the b is negative 4. That's a key thing. Remember, the b is not just a number, you know, you have to carry the sign with it. So it becomes negative 4. Negative 4 over 2 times the a value is 3. So that becomes negative 2/3. So if it's x minus h, minus give you a plus, minus, no, I'm gonna get a minus in there, x plus 8, sorry. So you're gonna get minus 2/3 in there. All right, so minus 2/3. So this one out of it, that is 3 over 2. So that this, or this, or this, right? So you really want to calculate the key. You really need the key to finish this one. So k now is 4ac minus b squared divided by 4a. The reason I'm writing by the formula multiple times is because maybe, you know, you'll have learned it the method way and not the formula way. All right. So it's a good formula to know though. So it's 4 times a. The a is a number from the x squared with the sign, which is a 3. And the c is a constant value, it's a positive 2. Minus the b squared. The b is negative 4, but when squared negative becomes positive anyway. Negative 4 squared. Remember, you're not squaring this minus enough, so this minus stays a minus. And divided by 4a. Divide this now by 4 times e. And the e is 3. Yeah. Write that better. Generated good. 3. All right, let's get a calculator. Drop it in here. Come fast. It's not wasting the time. It's not wasting the time. So the fraction 4 times 3 times 2 minus, that course will be 16 over 12. We get 0.6. With the k we're working out, you know. We get 2/3. So it's one with the 2/3. So the k equals 2/3 right here. Right? 2/3. So we can for that one positive 2/3. So the answer is, we'll put this one in now. That is 3 over 2. This one's the answer. So the h minus 2/3 and the k is 2/3. That is it. If you want do the process method and get it, no problem. All right, but the formula way is good for multiple choice. You don't have to show no work. Right, down here now. Same sort of thing. So you see this one now gives it a formula method, gives it a formula. So it's for you to know the formula to do this one now. See it? So inside here they have a h. It says plus h. So this one is not a h, you know. So this one is wrong. So I know that one is wrong. But this is not a h. I want to be ready. So remember we need b over 2a. That is just a a. So this is not a h. So this one wrong, right? So we can mark that as wrong. This as well is wrong. Right? Well, it's either this one or this one. So the h is good. So we're looking for the k now. This is not the correct k because that's our square on it. See? This is what caused this one not to be correct. So the correct answer is the last one. So I've marked on each one what causes it not to be the correct one. So it's like using a process of elimination. So you see, it's good to know the formula way as well. So this one is testing your knowledge of the formula. Okay? This is your h, and this is your k. All right? So that is it. So this one is a good one that tests your knowledge of the formula method. All right, so let's see the formula method is still good. Next question. Give us this one, and they want us to complete this quiz. The same thing again. Right? So the matter of determining which one it is. So for this one, what is the A? For this one, what is the A? What is the B? What is the C? For this one, the A is -2. Coefficient of the x squared is this -2. The B is -4. The number in front of the x squared, in front of the x is -4. And the C is a constant value, which is just a 1. And again, I want to calculate the H and the K. Right? Now, the A is -2, you know. So I know not this one, because that's a +2 right there. It's also not this one, so I can X out this one. And I can X out this one. I just put the 2 inside there. So I can X out this one. All right, so it's either this or this. So the question is, what is the H? You can notice this is a -1 in there, and this is a +1 in there. So I have to work out the K for this question. I just need to find the H, and the two of them have the same K. So one of those two is the answer. So I don't need to find the K, I just need the H. So we're working on the H down here, which is B over 2A becomes equal to, now the B is -4 over 2 times -2. That becomes a +1. So it's the one with the +1. The answer is this one with the +1. This has a -1 for the H. This is H, you know. Plus H is -1 in that one, which is not correct. So the correct answer is this one right here. So it's almost like we're using a process of elimination, guys. So remember the answers on the paper, we use the answers to help us we go. All right, this question now. Roots of this equation are. So this question is testing your ability of the discriminant to determine these are the possible nature of the roots. And it is the b squared minus 4ac that determines that. All right, so as a quick recap, where does this come about? Where does this come from? Remember, the roots will be equal to minus b plus or minus the square root of b squared minus 4ac, you know, divided by 2a. You know. So it is this thing under the square root sign that is used to describe the nature of the roots. Because right now, if that thing under the square root sign is positive, greater than 0, then this square root of a positive value is going to work out to something. So for example, if it's 4, we calculate square root of 4, you're getting a 2. For one root, you'll be adding the 2, and for other root, you'll be subtracting the 2. So you get 2 different roots if the discriminant is positive. If the discriminant is equal to 0, then this whole thing becomes 0. And so you would not be adding anything to the minus b, and you would not be subtracting anything from the minus b. And so what would that mean is that the 2 roots will become equal to this. 2 roots will become equal to that. The discriminant is equal to 0. And then now, if the discriminant under the square root sign is less than 0, meaning negative. Remember, you can't find the square root of a negative number, you know. You can't find a real square root of a negative number, you know. And so the roots would not be real if the discriminant is less than 0. So that's why if you want to know the nature of the roots, you have to calculate the value of this thing that is under the square root sign, which what that is, the discriminant. So we need to calculate what the discriminant is. We don't need the value itself. We only need to know if it is positive or negative or 0. We don't need the actual value. So once you see that it is coming out positive, or you see that it is coming out negative, you're good enough. Or I see that it is coming out to be 0. I don't need to know the actual value if I don't need it. I just need to see whether it's positive, greater than 0, less than 0, or 0. So 4ac, I'm going to work it out now. It is equal to 4 times b squared, b squared. Now the b is 6. So it's 6 squared minus 4 times a is 5 times c is negative 2. Now it's right here, so a negative 4 here and a negative 2 there. I'm going to call that to be positive enough. So I know that I'll be adding. All of this going to work out to be positive enough. So I'll be adding enough. So I don't have to know the value. This means it is going to be greater than 0 enough. But this is going to work out to be a positive enough because of the negative than the negative enough. So it's going to work out to be greater. I don't have to waste time and work out the actual value. I don't need the actual value. And once it is greater than 0, under the square root sign here, so I'm going to get a positive value. When I square root it, it means that I'll be able to add to that and then subtract from it, and someone get 2 different real roots. So the roots are real and different, see? Real and distinct, real and different. So this is the answer. So there's some explanation there. I'll come up on another one. I might just run through it a little bit fast. All right, everybody okay with that? Everybody okay?
Yes, sir.
All right, cool. All right, next question. Next question on the quadratics. So we'll finish the quadratics. We want to take a break, right? Another discriminant question. So same thing again. The root of this equation are what? Are what? The one of these. So the b squared minus 4ac again. So we're calculating b squared minus 4ac is equal to, now the b is negative 6. You're going to get negative 6 squared. That's going to become a positive minus 4 times the a, which is 3, and the c, which is negative 5. Again, this minus times minus going to make that a plus. And this also is going to be a plus. So this is greater than 0. I don't need to know the actual value. I just need to know whether it is greater than 0, less than 0, or 0. I don't need to know the actual value. So since it's going to be greater than 0, roots are going to be real and distinct, or real and different. 2 different roots. Distinct means different. 2 different roots. All right? That covers that. If it was negative, then the roots will be real and not distinct, real and different. If it was equal to 0, then the roots will be equal. All right? This one, the roots can be distinct and not real too, enough. It's negative enough. Distinct. When you get the roots that are not real, they occur in what we call conjugate pairs. You have to, when you do complex numbers, you know, but you get 2 roots same way, you know, when the roots are not real, you know. You get 2 roots that are not real, and they are conjugate pairs. They are conjugate pairs. All right. So they're also not the same. 2 real two not real different roots. All right, this one says, given that alpha and beta are roots of this equation, they're asking us to find this value. Now, this is the alpha. This is the sum squared, actually, you know, guys. Don't go working out anything, you know. This is the sum of the root squares, you know. This is what this is, you know. This is a sum squared, and this is a sum of the roots squared. That's what that is. It's not alpha squared plus beta squared asking for, you know. That have to be equal to alpha plus beta all squared minus 2 alpha beta. This that they're asking for is a sum squared. And the sum is minus b over a. So the sum, which is the alpha plus beta, is minus b over a. So this is a b, and the a is 1. So it becomes minus 3 over 1, which is minus 3. Right? Minus 3 over 1. Minus 3 over 1, which is negative 3. But you're squaring it up yourself. So the alpha plus beta squared, therefore, is negative 3. Where did I drop out the negative? Let me shift it over. That is why. It's negative 3. So we're doing negative 3 squared, which is the 9. So that's the 9 right here. All right, the 9. So note this is a sum squared, guys. Pay attention. It's not the alpha squared plus beta squared thing. This one down here, see alpha squared plus beta squared, you know. If alpha and beta are these, alpha squared plus beta squared. Now watch this now. When the equation is in this form, right? I'll show you something about the equation being in this form now. When the equation is in this form, we already have the sum and the product, you know. Because an equation can be written in form x squared minus the sum of the roots times x. I'm going to put s for the sum of the roots. Sum of the roots times x plus the product of the roots equals 0. You know? P for product and s for sum. Right? Now if I write it another way, it can be written as x squared minus alpha plus beta, that's the sum, times x, plus the product, which is alpha beta, equals 0. Now if you compare this with even this, you see that the sum right now is the p, because this minus exists right here. So the sum is actually the p, right? And the product is q. That's what we have been. So we have the sum and the product right here already, the p and the q, right? So we can write that alpha plus beta is actually equal to p, and alpha beta is actually equal to q. On the equation, I'm going to change this to blue. Right? But what is in red is just something I was showing you. Change it to blue. That's the problem. I'm changing it to blue. Write it in blue then. So I'm saying that the alpha plus beta right now is the p right here, and the alpha beta right now is the q right here. So what is this equal to? Let's go for a different color. It's like an identity. Alpha squared plus beta squared is equal to alpha plus beta all squared minus 2 alpha beta. So the alpha plus beta is p, so that becomes p squared minus 2 times the product, which is 2q. So the answer is p squared minus 2q, which is this. Are you okay with that? Everybody okay?
Yes, sir.
Yes,
Right, that. And then so they give back the same thing as I just told you here down here in our question. You know what I mean? So remember, it's x squared. This is a good thing to remember, you know. X squared minus the sum plus the product equals 0. Let's write that again. An equation can be written as x squared minus the sum of the roots times x plus the product of the roots equals 0. The equation can be written like that all the time. Put it down instead. Right? squared minus the sum of the roots times x plus the product of the roots equals 0. That's when you just make x squared alone the subject, put no constant in front of it. So you're looking for which one of them match this, right? So you want minus. So you see it's not this one because that's a plus. And it's not this one because that's a plus, right? So the one with the minus and plus the product. So you want the minus and then the plus. Note it is minus and then plus. Minus and then plus. So minus and then a plus. So this is it. That's it. Right? That one matches it. All right. Next question. Let's get a barrage of these. You're not fun in the exam, you can know how to do these questions. Believe me. You are being blessed right now with these questions. This one says quadratic equation, which has a sum of this, right? Sum of the roots, and this is the product. So that they give us the sum and the product. Remember, the equation is x squared minus the sum times x plus the product equals 0. So it's going to become x squared minus the sum. The sum is negative 2/3, so I will put minus 2/3 in the bracket times x plus the product. The product is 3/4. So plus 3/4 equals 0. So the question is, which one of these matches that? So we're going to realize that this is a minus minus, right? That becomes a plus. Then now what they have done, they have multiplied through by a 12. So if I take this now, multiply through by a 12, consider this as a minus. Let me write it first. So this becomes x squared plus 2/3 x plus 3/4 equals 0. Then I multiply through by a 12. Multiply through by 12 to get this 12x squared. I don't want integer values, integer coefficients. They don't want these fraction values as a coefficient. They want integers. This is gonna give me the 12x squared. Careful now. When I multiply this by 12, I'm gonna get 8. I'm gonna get 8, because I'm gonna get the 2 times 12 is 24. 24 divided by 3 is 8. I'm gonna get plus 8x. Everything positive. When I multiply this by 12, I'm gonna get same thing. I'm gonna get 9 because the 12 times 3 is 36. 36 divided by 4 is 9, but it's a plus equals 0. So everything positive. So it's same 8 and 9 that have it, but everything positive. So one with everything positive. Everything positive. So this is the answer right here. That's it. There are no minuses in there. So the one with the positive one. Because the same 12, 8, and 9, so you want the one with the positives. So you could have actually deduced it from right here. And never have to go any further from right here. Because this minus minus gives us a plus. It had to be the one with the 2 positives. So we could have known the answer from right here. All right? But you must get by this. All the values are the same. So it has to be the one with the positive. All right, but I'll work it all the way down. So we could have known the answer from that stage right there. All right, let's continue. The values of x for which this equal that. Now, I'm in the exam now, and the answers are on the paper now. Notice now. All the answers are different, Right? All the answers are, well, this is a 3. Right? So this is a 3. So if 3 don't work, I can eliminate these 2. But if 3 works, then I can either test the 5 or the 25. All right. Yeah. So anyway, take it. I have to use this one of the values. So I'm not going to try to solve it. I'm just going to put values in there and see which one works. I'm not going to try values. I'm not going to solve it. That don't make no sense. And the answers are right here on the paper. I'm going to try the 3 and the 5 in there. But if I try the 3 and it works, then I know says that this or this. If I try the 3 and it don't work, and I know is that this or this. And if it's one of these 2, then I'm not going to try the 9. I'm going to try the 5 or the 25. So it's a process of elimination. And you'll be smart with it. So I'm going to try x equals 3 first. I'm trying these values. Try x equals 3. I'm going to use a trial and error method. I'm not going to solve it. Solving is going to take a lot of time. I might take a lot of time. I don't need to solve it. I'm gonna see which one of them works. So if I try the 3, it's gonna be x plus 15 squared equals 64 times 3. Is this true? Let my calculator tell me. Let my calculator tell me if it is true. I have my calculator and I can use. Why did I close the calculator? Close it now. Man, let me bring up the calculator. Close the calculator. Hold on a second, guys. Let me see if I can bring up the calculator. I close the calculator accidentally. Where are you, calculator? I think this is it. All right, there you go. So I'm gonna try. This becomes 18 squared. I'm gonna see what 18 squared is. I can later on just subtract and see 18 squared, and I can actually subtract this to see if you get 0. So I'm gonna subtract 64 times 3. I get 132. So that is not it enough, right? So that is so the 3 don't work. 3 doesn't work. All right, that's what that is saying. All right, because 18 squared is, oh, it works. 18 squared is 324. I didn't put 18 squared a while ago. 18 squared is 324, right? And 64 times 3 is 1. So that don't work. So it doesn't work. So the 3 failed. So since the 3 failed, so you know the 3 failed. So I'm going to put the x on the 3. So since the 3 failed, I can x this one and x this one. So it is either this one or this one. I'm not going to test the 9, because if I test the 9, I'm not eliminating any of them. I'm going to test the 5. The 5 works, I know that this is the answer. The 5 don't work, I know that this is the answer. So I'm going to test the 5. So I'm going to try x equals 5 next now. So try x equals 5. The answer is on the paper. That becomes 5 plus 15 squared. Is that equal to 64 times 5? That's what we're trying to find out. So the 5 times 15 is 20. So the 20 squared is 400, right? Good. But what is 64 times 5? 320. So this don't work either. This don't work either. So the answer must, so this don't work either. So the answer must be that. Right? But I will mark that as my answer. But just to be sure now, I'm going to test them. All right? I'm going to test them. But if I'm rushing through my exam, that's it. Gone. But let's test them. Let's test the values. Let's test the values for this one. So it will be 9 plus 15 squared. Supposed to be 64 times 9. And it's supposed to be 25 plus 15 squared equals 64 times 25. Using 25. Let's just make sure. So it's 9 plus 15. That is 24, right? 24 squared. Yeah, 24. 24 squared. That's 576. And 64 times 9. 576. So it works for the 9. Let's try with the 25 now. The 25 plus 15 is 40. That's 40 squared. I'm 1600. 1600. And the 64 times 25. 1600. So that's the last one. But as I said, you know, we could just do these 2 calculations and we have the answer. Eliminate the 3 and eliminate the 5. So the answer must be the 9 and the 2 and the 25. All right. So that is that. I'm not even going to leave this on the paper. Just eliminate. It's a process of elimination. But all right with that? Have we completed the quadratics?
Yes,
I think we have completed the quadratics. I think the next part of it is inequalities. Next part of it is inequality. So I'm going to take a little short break now. Not a very long break, like 10 minutes. This is what time it is now. So, all right, so I'm starting back in 10 minutes flat. So I'm going to put on the timer for 10 minutes. So I'm going to start back. All right, so stretch your legs and so on. There is a clock. Clock's supposed to be here somewhere. Just put on this timer for 10 minutes start. All right, starting back in 10 minutes, guys. So I'll start back with the questions. Remember these questions, guys. You know, you are blessed more than you believe with these questions. I can tell you that. All right. And have a fun time in the exam room with these questions. The questions will be very similar to these. Super similar, not the same. All right. Hi again, students. Hello, are you there? Hello, can you see the screen still? Can you hear me?
Yes, sir. We can see the screen. We can hear you.
All right, so listen now. So I'm gonna jump and let us do some questions from another part of the syllabus, right? So we can always come back to these, all right? But this is like in module 1. So we're gonna go and maybe do some differentiation, just to get a nice mix of the paper. So we can always come back to this part later. So I'm gonna go up and let us do some differentiation. Let's just go straight up to the differentiation part. All right, now the logs and indices and so on. All these done already. I need to clear this off. These done already. So let's go and do the differentiation. All right, so differentiation begins. All right, differentiation begins right here. Number 35, right here. Okay, let's go. All right, so this one just simply wants us to differentiate this as a composite function. So differentiate a composite function, we differentiate it initially as if it is just x to the 5th power. But then you have to remember to differentiate the expression inside and multiply it, right? So using the chain rule. So the dy by dx for this function is going to be differentiate the whole thing first. So it's going to be 5 bracket 5 minus 2x reduce this power by 1 to the 4th power. But then you also have to multiply by the differential of what's inside the bracket. When you differentiate the bracketed term, you're going to get negative 2. Differentiate that to get negative 2. And so the negative 2 times this 5, or 5 times negative 2 is negative 10 bracket 5 minus 2x to the 4th power. That is the answer. Negative 10. So the answer is this. All right. Hold on a second. All right, so that is that. Next one. 35e. So this one wants us to calculate f prime of 2. Now, f prime means the first derivative. Prime here means first derivative. So that will find an f prime of x first, and it will substitute in the 2. Firstly, it's a composite again. F prime of x initially, differentiate again as if it is x cubed. It will be 3 times 2x plus 1. Reduces power by 1, we get squared. We'll multiply that by the differential of what's inside the bracket. Differentiate the bracket term, we're going to get a 2. So this f prime of x works out to be 3 times 2 is 6. So we're going to get 6 into 2x plus 1 squared. Therefore, f prime of 2 means that we'll plug in the 2 inside there. So getting 6 bracket 2 times 2 plus 1 squared. All right. So this really is 5 squared, which is 25. So it's 6 times 25 we're doing. 6 times 25 is 600, 150, 150. So the answer is 150. All right. All right. That is that. All right, next one now. This one says the stationary point on this function, but that's a quadratic, guys. That's a quadratic, All right, now you can differentiate it to find the stationary point, but you could also just transform the quadratic. All right. All right, so the stationary point. All right, so I'm just thinking of the best way to do it because it can be done without actually calculating, because like you have the quadratic function like this, which is x squared. And then this one now, x minus 1, means that they're going to have a root of 1. So it's like the graph is going to shift over to here. And this is where the stationary point is, 1, 0. All right? And this will become the x minus 1 squared. But go back to the traditional way to do it. We differentiate. So dy by dx, to find the stationary point, we put dy by dx equals 0. The stationary point, dy by dx is equal to 0. So you do dy by dx, get the gradient, you differentiate this again as if it is x squared. It will become 2 bracket x minus 1. Reduce this power by 1, it becomes 1. They differentiate what's inside the bracket, they're gonna get 1. So this really then just becomes equal to 2 into x minus 1 equals 0 at the stationary point. All right, dy by dx is equal to 0 at the stationary point. And if this is equal to 0, then the x minus 1 is 0, and so the x is equal to 1. And if you plug this one back inside here, right, the y value, so we can say, and the y value will be 1 minus 1 squared, is equal to 0. So the stationary point is 1, 0, as I said. Right? But if you could just transform the graph, then that is it. Anyway, that is that. Next part is first to differentiate this thing, right? And that's, we don't try to differentiate with the root symbol, you write it as a power. The first thing I'm going to do is write this as y equals 1 plus x cubed raised to the power half. The power is a half. Again, that's a composite function. So you differentiate it first as if it is x to the half. So you differentiate it, dy by dx is going to become half times 1 plus x cubed. You reduce this power by 1. Half minus 1 is negative half. You have to multiply by differential of what's inside the bracket. You differentiate the bracketed term, you're going to get 3x squared. I differentiate this one, you get 0. Differentiate the x cubed, you get 3x squared. Well, this negative power means reciprocal. All right. This 3x is going to be up on the numerator, this 3x squared. This 2 is going to be on the denominator. All right, so it's going to become 3x squared on the numerator over this 2 is under there. The negative places this expression under here, and then it is square rooted, means square root, power half is square root of the 1 plus x squared. And so that is the answer. All right, whichever one matches, that is the answer, which is not squared, cubed, 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 cubed. So the answer is this one right here. That one. All right. Then we go to number 35D. First derivative, want us to differentiate that. No, to differentiate this enough because this is just 1. You can write this as a reciprocal function like this. So I'm going to put y equals minus, that's the minus 1. I'm going to put in bracket the x squared minus 1 to the power minus 1 and differentiate it that way. So dy by dx becomes equal to, say I want to multiply by this power here first. It's going to become a positive 1. It's almost like we have the minus 1 there still. And then this goes up with the negative power right there. So there's a negative 1 multiplied by that negative 1, going to get a positive 1. Let me just show it for a good measure. Times by the entire thing, x squared minus 1. Reduce this power by 1, become negative 2. You have to multiply by the differential of what's in the bracket, which is 2x. Multiply by 2x, the differential of the bracketed term. And so this negative 2 means reciprocal power again, negative. So it becomes the 2x is on the numerator, 2x over x squared minus 1. And then this negative power becomes a positive power under here. So that is the answer. That's square. Right, so it's 2x over x minus 1 r squared. So the answer is this. But okay with that?
Yes,
But good with
sir.
that? All right, beautiful. Number 35. E. Again, so we're doing a series of differentiation here. So I want to differentiate this now. So we're using the quotient rule. And I always say to the students, quotient rule is very easy. You start with the bottom and you end with the bottom squared. All right. So it's the bottom times the differential of the top minus the top times the differential of the bottom over the bottom squared. So if this is my y, my dy by dx will become equal to, I'm writing the bottom first. Let's write that down first. X plus 3. Right on the bottom first. And I'm differentiating the top. When I differentiate the top, I'm going to get 2x. Then you subtract the top, I need some space. You can make this larger and write it smaller. With some space. Let's see if we can do it like that. Right. Then I'm going to minus the top now. Minus the top. So remember, there's a minus inside here, not a plus. And the top is x squared. And then we're differentiating the bottom. Differentiate the bottom, I get 1. And divide that by the bottom squared. X plus 3. Let's square it. So what did I do? I started with the bottom. I wrote down the bottom first. This denominator, I wrote it down first. The bottom. When I write down the bottom, I know how to differentiate the top. Then I have to switch on the order now, but I put a minus. Then I write on the top next. And I differentiate the bottom. And I finish off with the bottom squared under here. So it's simple. You start with the top and end with the bottom squared. It can't go wrong. But when I write down the top, I have to differentiate the top beside it. Then I switch around the order. I then write down the top and differentiate the bottom. All right, so I start with the top and end with the bottom square. So it's a matter of simplifying this now and see which of the answers it matches. Right? So I'm looking at the answers as I go. I don't want to do unnecessary work. Right? So let's simplify it first. It's gonna be expand this out. It's gonna be 2x squared plus 6x minus x squared divided by x plus 3 r squared. Well, this and this gives me x squared alone. All right, x squared alone. So I'm gonna get x squared plus 6x over x plus 3 squared. I'm gonna factorize x out of the numerator. X into x plus 6 over x plus 3 squared. So looking for that answer, which happens to be the last one right here. That is it. So remember, we're differentiating a quotient. We start with the bottom and end with the bottom squared. That's the easy way to remember. Don't have to use the UV business, all right? Don't need that UV business. That's remember. Right on the bottom first, differentiate the top, and switch them around. And remember, there's a minus up here. Minus the top and the differential of the bottom over the bottom square. All right, next one, to differentiate this. First, we're gonna write it. That's what this means, to differentiate this expression. So we're gonna write this as y equals 7x squared plus 4 to the half. This root is half, power half. So dy by dx is, again, you're going to differentiate it as a composite. All right, differentiate the whole first. So it becomes a half into the entire thing. I think I need some more space. So let me zoom it up again. I'm differentiating this, right? Differentiating that. So let's go. So dy by dx is going to be half into, right by the whole thing, 7x squared plus 4. Reduce this 4 by 1, it becomes minus half. You have to multiply by the differential of what's inside the bracket. To differentiate this thing, you get 14x. Differentiate this, 4, you get 0. That is it now. That will simplify. Firstly, half of the 14x is 7x. That's going to be on the numerator. This negative power is going to put this expression on the denominator with the same power of a half, which is the square root of 7x squared plus 4. So this right now is my answer. 7x over that, which happens to be this answer that it is right beside, right here. All right, is that more differentiation right up here. Again, this is a quotient to differentiate now. This thing, same process. Start with the bottom and end with the bottom squared. I'm not going to write down the bottom first, which is 5 minus x. Then I'm going to differentiate the top. When I differentiate the top, I'm going to get 2. I'm going to change the order. I'm going to now write on the bottom. I'm going to now write on the top, which is 2x minus 1, and differentiate the bottom. When I differentiate that bottom, I'm going to get -1. So I get -1. And divide that by the bottom squared. You're going to square this now. 5 minus x squared. All right? I'm going to expand out the top because it's all simplified. Expand this first. I'm going to get 10 minus 2x. Now be careful for the negatives over here now. This -1 and this negative renders this whole thing positive. You know? So like I'm writing back this because the negative makes me multiplying this thing with a positive value. So I just need to write that back down. So I'm going to put back the plus 2x minus 1 all over the 5 minus x squared. All right? And this minus 2x and this 2x wipe out each other. And then the 10 minus 1 is 9. So it works down to 9 over 5 minus x squared. 5 minus x squared. All right? So 9 over 5 minus x squared, which is 8. All right, that is that. Who's that? I'm on that way. All right, cool. All right. So
Take some from Winston.
huh?
You did 5 grams from Winston.
Oh, yeah, to take 5 grams from Winston?
Yeah.
Oh, all right. All right, guys. Now come to these trig functions to differentiate now. All right, I'm going to differentiate these trigs. Now remember, when we differentiate sine, get cos. We also have to differentiate the expression within, which is the 3x. We differentiate cos, we get minus sine. We also have to differentiate the expression within. So you normally differentiate the expression within first and then differentiate the whole. Differentiate the expression within and then differentiate the whole. When you differentiate in the whole, when you differentiate cos, you're going to get minus sine. And so I already know. I'm going to differentiate this now. I'm going to put it right here. The one that has space, I'm going to put it right here. I'm differentiating this right here now. All right, and it's actually 2 times we have to differentiate. You know, this double prime means twice. All right, so I'm going to write this right, f prime equals. All right, I'm not going to bother to put the bracket on the x. We differentiate sine and get cos, but I'm going to differentiate the 3x, the 3 first, and get the 3x first and get 3. I'm going to get 3, and then I'm going to get cos of the whole 3x again. When I differentiate the cos, I'm going to get minus sine, but differentiate the 4x first, I'm going to get a 4. Because I know that when I differentiate the cos, I'm going to get minus sine. The minus is going to give me a plus. I'm going to put the plus from now, put the 4, and then put the sine of the entire function 4x. But understand that so far?
Yes, sir.
Good. I have to differentiate it again because I want a second derivative. So f double prime now equals, I'm differentiating this. I'm differentiating cos, so it's going to become a minus. I have to differentiate the 3x first and get 3. Then the 3 times 3 is 9. So I'm going to get a minus 9. Minus 9 sine 3x. So I get to differentiate that, you know. I'm differentiating this again now. Everything's going to stay positive. I want to differentiate sine, I get cos. If I differentiate the 4 first, I get 4. 4 times 4 is 16. So I'm going to get plus 16 cos of back the same 4x. That is the answer, you know, right here. This is my x double prime. I'm looking for it. So it looks like the last one. The last one. That is it. All right, that is it. All right, next question. It says the gradient at this value on this curve. So basically, get the gradient is dy by dx. So the gradient is dy by dx. So this, when I differentiate it, I'm going to get a gradient which is dy by dx. I differentiate sine, I get cos, is cos x. We're going at x equals pi by 6. Now pi by 6 is what? 30 degrees. And so this becomes a cos of pi by 6. So it becomes in a cos of pi by 6. Cos of 30 degrees is root 3 over 2. Now you can use the calculator and work this out as well. Let me see what the calculator will give me. Some calculator will give you the root 3 over 2. But the answer is root 3 over 2 right here. This is the answer. Let me see what the calculator will give me. Some calculator will give you the root 3 over 2. I will give you the decimal form of root 3 over 2. So let me work it out. First, I need to put the calculator in radians. Right now, it is in degrees. You can see the DEG at the top of it there. It is now in radians. I'm going to do cos of pi by 6. So I get 0.866. Let me see if it gives me as a, there you go. See, root 3 over 2. So you want a calculator that can express it that way for you. Root 3 over 2. All right, beautiful. So that's what you want. If you have a calculator, can do that. So the answer is root 3 over 2. Right here. All right. See, same thing again, same question basically, but I put cost now. So now remember, when differentiate costs, you're gonna get minus sign now. So this one now we'll differentiate. This one now we're gonna use the same approach. We're gonna get dy by dx now equals minus sine of x. Let's zoom it up. Right, it's smaller. So we're gonna get dy by dx equals minus sine of x. So you're now doing minus the sine of pi by 6. Pi by 6 is 60 degrees. The pi by 6 is 30 degrees. Sine of 30 degrees is a half. So this is a half. The answer is minus half. So the answer is this one. If we put it on the calculator, not there, not there. After this, after that, so put on the calculator, it changes the costs, it changes the sign, put minus in front of it, you get minus a half. All right, that is that, minus a half. Now you have to remember, we differentiate cost, you get minus sign, and the gradient is dy by dx. All right, so you can look out for those. All right, next part, this one right here now. So this one says, at this point, dy by dx is 0. Or dy by dx is 0, it means that it's a stationary point. This means that we have a stationary point, because at a stationary point, dy by dx equals 0. So we have a stationary point. So we can write that. It's a stationary point, because dy by dx equals 0. Then the dy by d2 by dx squared is negative, less than 0. When the second derivative is less than 0, we have a maximum point. That indicates that we have a maximum stationary point. the stationary point is maximum. So this point is a maximum stationary point. They say the point is maximum. Second derivative is negative. We have a maximum stationary point. That is the answer. The less than 5 means negative. And the dy by dx equals 0 means that it's a stationary point, which is either a maximum or minimum. So that point of inflection, that's not a necessary syllabus. That's when the second derivative is equal to 0, but that's not a near syllabus. Right? So this must be on paper that is a source that is not a near syllabus. All right, this next one is a similar question, guys. These two similar. You know? Just start to put f double prime now. F double prime is the second derivative and like dy by dx. That's what that is. You know? All right. It says the curve C with this equation as a stationary point. So they tell us that this is a stationary point, and they say f double prime is that. Then that point is what? Now, if f double prime is this, we want to know whether it's positive or negative. Right? So let's zoom up again. On this f double prime really is like our second derivative, d2y by dx squared. Right? That's what it is. It is x to the fourth power minus 15, and this is the x. So it becomes negative 2 to the fourth power minus 15. This equals 1, you know, because this is 16, you know. 16 minus 15 is equal to 1, which is greater than 0. And when the second derivative is greater than 0, this means that we have a minimum point. So a minimum point. The stationary point, as I told us about, is actually a minimum. But the second derivative is greater than 0. All right, so it's a minimum point we have. So you see the similarity in the two questions that we just did. Different values, different way of representing it, but you know, it's the same sort of thing that it's testing. All right, that finishes that. Next one says the equation of a curve is this. What is dy by dx? So this is testing our knowledge of the product rule. This is not the product rule we're testing. All right, so let me zoom it up and see if we can do it right here. Now remember, the product rule now is one where you keep the first and differentiate the second, plus keep the second and differentiate the first. All right, the plus situation. We differentiate in this part of it, we recognize it as a composite. All right, treat it like a composite. Already, I'm going to do it right inside here. Show the work. I'm going to do it right here. So I'm going to say the dy by dx is equal to, I'm going to keep the first, which is the x squared plus 2. I'm going to differentiate the second one. I'm differentiating this now. Treat it like a composite. So because it's a composite, I'm going to put it in a square bracket. And I'm going to differentiate this inside here now. So first, you treat it like it is x cubed. So it will become 3 times the whole thing. The x minus 1 squared. You have to differentiate what's inside the bracket, which is just a 1 this time. So they don't change anything. Plus, I have to keep the second now, keep this as is, which is the x minus 1 cubed, and differentiate the first thing. I differentiate that first thing, I'm going to get 2x. By differentiating this alone, this differentiates to 0. That's it. So look at which one of them equal this now. So if you notice, you can simplify it first. Let's do it under here, double letter space. Let's do it under here, right? So we really know this becomes a product of 3 and these two things. All right, and this now is a product of 2x and this. So if you look at it, we have a common factor. We can do it straight, you know. We have a common factor of x minus 1 squared. We can get the highest common factor of x minus 1 squared out of those two terms. So let's do it. Let's write it down. So this down here becomes that dy by dx is equal to, I'm going to factorize the x minus 1 squared. Out of this expression, I'm going to do it with a 3 and that bracket in the bracket, right? I'm going to get inside here 3 times this, all right? 3 times that, which becomes 3x squared plus 6. Then now, out of this one, I'm factoring out a square from that. So I'm going to be left with x minus 1 times this. What you know? X minus 1 times 2x. That's a factor that I'm leaving out of that. That is to go here. I don't want that space, so I can't show how that works. So I need to multiply this out and drop it here now. So it's going to be x times 2x is 2x squared. I'm going to get plus 2x squared minus 2x. So the question is now, which one of these this one equal? Let's look at it. So I know this one out of it, right? Because I'm looking for the one with the square, x minus 1 squared. Watch this now. This 3x and this 2x is 5x squared, 5x squared. I know that it's one of these, right? Look at the x values. This is only minus 2x and the plus 6. So I'm going to get 5x squared minus 2x, 5x squared minus 2x plus 6 in this bracket. And the x minus 1 squared out here. That's what I'm getting. So the answer is C. Let's put it in purple right here. That is the answer right there. But okay with that?
Yes, sir.
Right.
Yes, sir.
Cool. Now let's look at this next one now. This one says a curve is given by the equation this. This is the equation of a curve right here. And the curve has the stationary points occur where? Remember, at the stationary point, dy by dx equals 0. So you really just want to differentiate this, put it equals 0, and then see which one of them is going to give us those as our x values. See? The values of x for 1. Right? Values of x for 1. So we're going for where dy by dx equals 0. So the stationary point we know is where dy by dx. Stationary point is where dy by dx is equal to 0. So I differentiate this then. So we differentiate that, we're going to get 6x squared. Differentiate that, we're going to get minus 6x. Differentiate this, we're going to get minus 12. Differentiate this is 0, and you put in this derivative equals 0. That's what we're solving. Divide 2 by 6, we're going to get x squared minus x minus 2 equals 0. And so we're going to factorize this now to get the factors. We know the factors, we know the root. Factors of the x squared is x and x. Factors of this 2 is 1 and 2. This tells me that the two signs in the bracket are different. This tells me that the larger product must be negative. Far product is the negative, and near product, the larger one must be negative like the middle term. So the far product is greater, so I put the negative here and a positive here. So this one gives me a factor of 1, negative 1. This one gives me a factor of 2. So those are the x values. Not a factor, a root of negative 1 and a root of 2. And so it's negative 1, 2. So the answer is B. Negative 1 and 2. All right. So normal stuff. This one says the gradient function dy by dx of this. So in other words, I want us to differentiate this. Easy again. So remember, it's a function within a function. You have to differentiate the function within. And you have to differentiate the whole function sign. To differentiate sign, I get cos. Differentiate inside this first. So let's go. So from this, the dy by dx is going to be differentiate the expression within first. We differentiate this, we're going to get 4x. Because differentiate this, we're going to get 4x. They differentiate the whole function, which is a sine function. Differentiate the sine function, you get cos. You're going to get cos of the entire function within 2x squared plus 1. That is the answer, which is A. Answer is A. Yep, A. Right. So the answer is this one right here. That's it. All right, nice and easy. All right, good. Continuing over here. Differentiation again. Differentiation again, more differentiation. We're going to the trig differentiation now. So again, this one to differentiate. This is a sine function. We differentiate sine and get cos. That's the expression within. You have to differentiate the expression within. We differentiate the 2x to get 2. The 2 I'm multiply by the 5 and give me 10. So I'm going to get 10. Differentiate the sine function. This is we're going to get cos. So you're going to get cos of the same 2x. That is it now. The answer is this one. Nice and easy. So some far more easier than others. All right? But it don't matter. Each of them carry 1 mark. We differentiate cos, when you differentiate cos, you get minus sine. Well, again, you have to differentiate expression within, which is 2x. We differentiate 2x to get 2. But it's going to be minus. I'm going to put minus 2 because I know that I'm getting a negative. And differentiate the cos to get minus sine. So the minus there, I'm going to write the sine of the 2x. That is the answer. Minus 2 sine 2x. This is it. That is it. All right. Moving right along. More tricks to differentiate. But this is a normal power function. Right? So I'm going to get, let's put it here. dy by dx is differentiate the normal power function. You're going to get 4x for that. You're differentiating the cos, you're going to get minus sine. That's a multiplying constant, so it remains. It's going to become a negative 3. And differentiate the cos. I put the negative already for the minus. Differentiate the cos, you get minus sine of x. Differentiate x, you just get 1. So this don't change anything. That is it enough. 4x minus 3 sine x. The answer is this one. Nice and easy. More of the same. More of the same. Another power function, a trig function combination. dy by dx again equal. Differentiate the power function as normal. Get 4x. Differentiating sine now. Differentiate sine and get cos. So there's no change in this. That is a positive. So it's a plus 3 cos x. The last one. Let me differentiate sine and get cos. You differentiate sine, you just get cos. All right? And the expression within is just sine, it's just x. You differentiate x, then you will get 1. They don't change the value up front. All right? That is that. Then we'll go to some application now. This one says the point P lies on this curve. The value of the gradient at the point P is what? So we have to differentiate this to get the gradient and then plug in the 1 on the point. On the gradient. The gradient is dy by dx. The gradient is dy by dx. That's what I want. And I want that at this point. So we're going to have to differentiate that as a quotient. So we have to use a quotient rule again. All right, so we're taking this and we're differentiating it down here. Quotient rule, ready again. So dy by dx equals, start with the bottom, end with the bottom squared. So I'm going to write down the bottom first, which is 2x minus 1. Because I write down the bottom, I have to differentiate the top. When I differentiate the top, I just get 3. And I reverse it, minus, now I write on the top, which is the 3x minus 2, and differentiate the bottom. I differentiate that bottom, I'm going to get a 2. And I'm putting everything over the bottom squared, 2x minus 1 squared. So what did I do? I wrote on the bottom first, right here, and I ended with the bottom squared right here. So it's easy reference. Start with the bottom, end with the bottom squared. Let me mark them for you. Start with the bottom and end with the bottom square. The bottom square, so the bottom here. That's my point of reference. Start with the bottom and end with the bottom square. When I write down the bottom, I have to differentiate the top. Then I minus the top. Switch them around, minus the top and differentiate the bottom. And then I put everything over the bottom square. All right, we want this at the point 1, 1. So it's where x equals 1. We can simplify this first. If you want, so this becomes equal to, expand this, I'm going to get 6x minus 3. Remember, this is like minus 2 now, you know. So like I'm multiplying minus 2 times this bracket. So be careful with the negatives. So like minus 2 times 3x That's minus 6x. I'm going to put minus 6x. And then minus 2 times negative 2. Give me a positive 4. Care for those signs. Positive 4 now. All over the 2x minus 1 squared. And then this 6x wipes out this 6x. So I'm left with 4 minus 3 is 1. 1 over 2x minus 1 squared. All right. I'm going to plug in the values now. So at P11, the x is equal to 1. I'm going to put the 1 in there. And so my dy by dx is going to become just 1. Answer is 1 enough. First one. I'm going to get 1 over 2 times 1 minus 1 squared. And this is 1 enough. So the answer becomes 1. 1 squared is 1. So the answer is 1. So the gradient is 1. That is the answer. So much work, so just come down to an answer of 1. But that's how it is, no problem. All right. It is that. All right. So let's go. All right. Let's continue. More differentiation. It'll give us this thing to differentiate twice. Now, because this is under here. I can choose initially to write this as a power function now. So I can write this as x squared plus 6x to the minus 1. This means I have to differentiate it twice. I differentiate this twice and then I write it back without the negative power. If I differentiate the first time, dy by dx is going to be differentiate the x squared. I'm going to get 2x. When I differentiate this, I'm going to multiply by this negative power. I'm going to get negative 6x. Reduces power by 1. Subtract 1 from it to become negative 2. You have to differentiate this again to get the second derivative. So d2y by dx squared would be, differentiate this 2x, I get 2. I'm differentiating this now. I'm going to multiply this negative 2 by this negative 6. So I get a positive 12 x to the minus 3 now. I'm subtracting 1 from this. I get x to the minus 3. So it really then becomes 2 plus, this goes on my numerator, and this means over x cubed. That's what negative power means, reciprocal. So it's 2, 12 over, did I make a mistake? 12. Oh, 16 I gave me, I wrote 6 here. 16 I gave me, and I wrote 6. So this is 16. This is 16. So this should be 16. And 2 times 16 now is 32. This should be 32. Put in the answer wasn't there. This is 32 here. So just that I wrote on the wrong thing. It was 6 and not 16. It was 16 and not 6, right? So the answer is one of the cube. Careful, one of the cube. See, this have a square on it. I almost mark that one in it, one with the cube. So this answer. All right, it is that. Yep, it is correct. Number 40, integration now, guys. We're gonna go straight into the integration now. So we've just gone through the differentiation. We can just go straight into the integration now. All right, integrate all of these functions. Then we have statistics coming up after. So we can finish integration. We can finish today. Now, what time is it now? No, we can finish today, man. Just stop that. All right. The 3 and that. All right. So we're going to integrate now, guys. Integrate. Remember, integration is a reverse process of differentiation. Oftentimes, I always say, double check. If you integrate, what you can do is differentiate the result to see if you would get back what you integrated. Because integration is the first process. We have learned integration first. So usually you understand integration well. All right. Integration is a reverse process of differentiation. So if you integrate and you get something, just differentiate back what you integrated and see if you get back what you integrated. All right. All right. Differentiate what you got to see if what you integrated, you get it back. All right. So this one says find the value of A. We want the value of A such that integral from 0 to A. This is A up here now. This is A. Right? That's A. So if this integral is equal to 50, find the value. So it's almost like we're performing this integration. I'll put it equal to that 50 over 3 and work out the value for A. So what would this integrate into? That's the first thing. So we're working this out. So this will become, working it out down here. So integrate the x squared, you get x cubed over 3. Add 1 to the power divided by the new power. So we're going to get x cubed over 3 divided by new power. Integrate a constant, you just put the x beside it. I'm going to get minus 5x. And if I double check this, differentiate this, I would get that back. All right? Now, all of that is under the limit of 0 to A. So I'm going to put in the limit brackets 0 to A. And we know that answer is 50 over 3. So that was solving for the A now. So remember now, we're going to substitute the A into these values first. Subtract what you get when you substitute the zeros. Now the 0 is going to give you 0 now. You plug the 0 here and you're going to give you 0 this time. So first I want to plug in the A. So I'm going to get A cubed over 3 minus 5A in the first bracket minus, when I plug in the 0, I'm going to get 0. And that equals 50 over 3. So I'm solving this for A now. But I don't have to solve it all the way out, you know, but the answers are on paper. I just need to see which one works. First, I'm going to multiply 2 by 3 to get rid of the fractions. Multiply by 3. I'm going to multiply this by 3. Just to get rid of these fractions, right? And this 0 is will be eliminated. So I multiply by 3. I'm going to get A cubed from this. This is going to become 15A. A cubed minus 15A equals, and this becomes 50. I'm not going to solve that. And the answers are on the paper. I'm going to see which one of them works. I'm just going to try the values and see which one works. Why work it out? And I can't have the values in front of me to work with. I want to know A cubed minus 15 equals 50. All right? So let's try the 10 first. No problem. Let's try the 10 first. So 10 cubed, not that thing, but I'm just showing you. 10 cubed minus 15 times 10. And I'm getting that, not 50. Next value to try is the 8. I'm going to change the 10 to 8. Change the 10 to 8 there. Change the 10 to 8 there. All right, and that's what I'm getting. That won't work either. So I'm going to try the 6. 6. 6. That don't work either. So then there's a 5. I should have known it's a 5 from the beginning. Right? 5. So the answer is A, 5. So A equals 5. So try and see that A equals 5. So you try A equals 5 and it works. So the answer is 5. Let's click on thing. You don't waste time and try to solve that. When you have the answers there, to just plug in and see which one works. Okay? You know, make no sense. Just plug in the answers and see which one works. So this is a similar question, you know, with different values, you know, same as that. With different values. And they tell us that the A is greater than 2. They didn't tell us that here, but naturally, once you see the integral, the number at the top is always greater than the number at the bottom. Right? The upper limit and the lower limit. The limit at the top is greater than the limit at the bottom. So anyway, we're doing this the same way, guys. Same as we just did. Same process. Different numbers, same process. But this time we're going to have to plug in the 2. All right? So let's go. So we're doing the same thing. Let me close this out. I'm going to try values again. We'll finish. This is a lot of space to work with, so we can just work it down. So we're going to integrate this first. All right, we integrate the 6, you get 6x. We integrate the 3x, you're going to get 3x squared over 2. You're going to get plus 3x squared, add 1 to the power divided by the new power. Put these in your limit brackets, A2 and all that is equal to 72. Then I plug in the A first, and then when I plug in the 2 and subtract, and plug in the A, I'm going to get 6A plus 3A squared over 2 in the first bracket, minus plug in the 2 now. Let me shift this over, because I want a space. I'm going like, I don't want to take my time. So plug in the 2 now. When I plug the 2 inside there, I'm going to get 12. Let's put that 12. Plus, when I plug the 2 inside here, I'm going to get 4 over 2. Over 2 is 2, so it's going to work out to 6. I can just write this. I'm going to get plus 6. And all of this is equal to 72. All right? Now, what is this? This is 18. And sub minus 18, this is so the minus 18 will come over and add to that. So I'm going to get 6A plus 3A squared over 2 equals 72 plus 18. 72 plus 18 is how much? 90 that. But I understand that? 72 plus 18 is 90, right?
Yes, sir.
Good. And then I want to see which of these answers now. Working this. I'm not going to solve it. Multiply 2 by 2. Well, this can be divided 2 by 3 to simplify it. Right? It can be divided 2 by 3 to work it down and get 2A plus A squared over 2 equal to 30. All right? If I divide 2 by 3, let's write it. Divide by 3. And then now to get rid of this fraction, I can multiply it up by 2 again. And then I get 4A plus A squared equals 60. So on 4A plus A squared equals 60. I'm not going to use my calculator. I like a 6, you know. Like a 6. Like a 6. You can try this. So try X equals 6. Try A equals 6. Try A equals 6. I get 6, 4 times 6 here, so plus this is 6 squared. That equals 60, you know. Because it's a 4 times 6 and 6 times 6. 4 and 6 is 10. 10 times 6 is 60. So it works. So answer is the first one again. So the change of values, but the working out is the same. All right, that is that. All right, let's see the set. What the set again? This one now. What is the answer for this? Let me explain this there now. I can maybe sketch it up here for your explanation. Let me sketch it and show you. So what they're saying is that you want to integrate f of x between 0 and b. They're saying our value c is between 0 and between a and b, not between 0, between a and b. Which of these is correct? So like you break down this integral into a sum. So if I were to sketch it out for you to illustrate it, it is like you have a function. All right, a simple function. Let's make it simple. All right, let's say I have a function like that. This is the y-axis and this is the x-axis. Let's keep it simple. And let's say this is your function, right? This is your function. Let's say the function go like that. That's a function f of x. And then you have these limits, right? You have the limit of a, you have the limit of b, and you have c somewhere in between here. That's what this is saying. And this integral right here will give you all of this area. Let's show the area in blue, in green. We'll give you all this area now. That's what that integral is gonna give you. But then I could break down that integral in 2 parts. You could divide it right here and get the sum up to c, and then get another part between c and d. So the sum in here plus the sum in here is equal to the sum of the whole thing that we had before. That's what basically saying now. So you're looking for that. So the sum from A to B is equal to the sum from A to C plus the sum from C to D, C to B. So you're looking for that. Right? This is the x, and x is the sum from A to B, the whole thing. So what it breaks down in? It breaks down into the sum from A to C plus C to B. So you want A to C. So A to C here, A to C. But this now is B to C. You don't want that. You want C to B. So you have A to C and then C to B. So this is the answer right here. So the sum from A to B means that you can take the sum from A to C first and then add the piece from C to B. That's what does that mean. So that is the answer. But good at that?
Yes, sir.
All right. Simple. And so basically, so what the question I want to make this part the subject alone. Then basically, if you want that part to be the subject, then you could transpose and say it is the whole thing minus the first part here. We'll do it that way as well, you know. So they want the sum for here alone. It will be the entire area, which is the area from A to B, minus the area from A to C. That will be equal to the area from C to B. So instead of giving you that, it could also give you a different situation. Because like you have this equal as these two. You can make any one of these a subject by subtracting this and leave this as a subject, or vice versa, or the other way. Or to leave this as a subject, you subtract this one. All right, so they could also give you a question with the difference. All right. Anyway, that is number 40. Look at this one now. They tell us that the integral of that is equal to 6. And asking us for this. The difference between this and this is that you have a multiplying constant in here. But this multiplying constant can come out to the front. All right. So this whole expression can be written as 4 times the integral of f of x dx from 1 to 4 plus about the same 5. We already know that this right here, so is 6 this here, so this inside it is integral is 6 now. So this therefore is really 4 times 6 plus 5. So 6 4 are 24, 24 and 5 are 29. This equals 29. The answer is 29 right here. But I understand that? Very good?
Yes, sir.
See another one here. Same thing. Just that at different values, right? They tell us that its integral from 1 to 7 is 5. Then I want this again. So this 2 is only different between this and that. But as a multiplying 2, it can come outside. So we approach it the same way. This can be written as 2 times the integral from 1 to 7 of f of x dx plus the 3 not troubling anybody, plus the 3. And this integral is 5. So this therefore then becomes 2 times 5 plus 3, which is equal to 13. So then says this 13 right here. That's it. All right, then we'll come to these composite integrals. I call them composite integrals. And it is a type where the differential of what's in the bracket is a constant. So you can do the reverse process on these because you're going to divide now by the differential of what's in the bracket. When you're differentiating, you multiply by the differential of what's in the bracket. When you're integrating, you divide by the differential of what's in the bracket, but only when the differential of what's in the bracket is a constant. So we have to divide by the 3. All right? And they're doing this between limits. So I have to put our limit brackets. So let me zoom this up and do the work right here. So this initially is going to become equal to, let me put limit brackets first. All right? So you integrate it first as if it was x cubed. So you're going to add 1 to the power. So you're going to become 3x plus 4. Add 1 to the power, get 4. Divide by that new power. But then you also divide by the differential of what's inside. You have to divide by the 3 as well. You have to remember this, guys. put in back your limit brackets 2 and 0. Don't assume that 0 gives you 0. You have to plug in the 0 there and see what you get. Not every time 0 gives you 0. All right? So you're going to plug in the 2 first. All right? This under here says 12. You know? We can actually just factor out the 12 on a year, you know, like so. You can put it as 1 over 12 and put back our limit brackets 3x plus 4 to the power of 4. Let me make this a little smaller. And put back the limit brackets 0 to 2 and keep this 1 over 12 as a constant. So it's going to become equal to 1 over 12, and then inside here now I'm going to apply the 2 first. When I plug the 2 right here, I'm going to 3, 2 is 6. 6 plus 4 is 10. I'm going to get 10 to the 4th power minus, when I plug in the 0, I'm going to get 3 times 0 is 0 plus 4. So I'm subtracting 4 to the 4th power. But I can see that?
Yes, sir.
So that's what I'm working on, right? So let's do it the easy way now. Go off with the calculator and do it. No problem. So I'm working on 1 over 12 into 10 to the 4th power minus 4 to the 4th power. 812. Answer is A. And they say unit squared. I don't know why they say unit squared. Maybe this came from an area question, but no matter. It's 812. So they didn't have to put on this unit squared on this, but it no matter. I just give us something to integrate and write the values there. Answer is 812. Whether the unit squared is here or not, the answer is 812. Right? So don't make that into a problem. All right, next part. So sometimes these questions are pulled off another question. You know? So it might have been pulled off an area question. That's why they have the unit squared there. All right, so this one now, similar question, have the limits and stuff. Now, again, you want to write this as a power function. So you want to bring this up and write it as the power negative 2. So the first thing I'm going to, let me zoom it up so we can have some space to write, right? Small. All right. All right. So I'm going to rewrite this first as a power function. Right? I'm going to put it as the integral from negative 4 to negative 1. And note these negative, I have to be careful now, negative. I'm going to write this as 5x minus 2 to the negative 2 and integrate it as a power function. I don't want to be integrating like a fraction. At advanced level, you don't learn how to integrate fraction yet, really. So when you get fractions and so on, complicated expressions to integrate, write it out as a power function. Expand it out if you can and write it out as a power function. Right? So just bring it as a simple power function like that, like a composite. You try to get it in the form ax plus b to the n. You are free to integrate that. You integrate the expression like that, you get ax plus b to the n plus 1. Add 1 to the power. Divide by the new power of n plus 1. Also divide by the a. That's what you get. And if there's no limit, you put a plus k as a constant. If there are limits, then you put the limit brackets around it and you plug in the values. So 1 and 2, for example. All right, but yeah, you have to integrate this thing right here. And remember, it is ax plus b. Add 1 to the power, get n plus 1. Divide by a new power, n plus 1. Don't forget to also divide by the differential of what's in here, which is the a. All right, so you're trying to get them to look like this. Trying to get your integrals to look like that. You get the fractions, all right? So that's what we did right here. Then now we're gonna proceed. When I add 1 to this power, it's gonna become negative 1. When you add 1 to negative 2, it can become negative 1. So I'm gonna get the 5x minus 2 to the negative 1. Divide by the negative 1 power, and also divide by the differential of what's in here is a constant 5. putting those between my limit brackets, -4 to -1. All right, careful with those negative signs. All right, now this -1 power, don't work with -1 power from here. You can put in the calculator still now, but don't work with -1 powers. This -1 and that -5 under here, I can bring it out here as negative of 1 over -5. So I'm going to do that. I'm going to write this now as, let's write it as 1 over -5. I could put -5 over 1 into, let's make this smaller again. So we can have more space, show the work. All right, so I'm going to write the 5x minus 2. All right, so this minus 4 means reciprocal. So I'm going to put it now as 1 over 5x minus 2. And I'm using the limits between -4 and -1. I'm ready to work this out now. So it becomes equal to the 1 over -5, same as -1 over 5. Stays on the outside. Plug in the -1 first. Careful now. When I put a -1 here, it becomes -5. -5 and -2 is -7. So I'm getting 1 over -7 minus, I have to plug in the -4 now. I plug in the -4 here, I get -20. -20 and -2 give me -22. So I'm getting 1 over -22. You have to have no words in there. You can put that in a calculator exactly as it is now. Or you can write this minus is a plus. You can just put this in the calculator exactly as it is. All right. You don't have to go any further. Just put it in the calculator exactly as you have it here. Let's see what you get. But they have the answers break out here for us. Wow. So the answers break out for us, guys. So I didn't even realize this. I'm going against my own advice, which is to check the answers. So let's expand it out. All right, let's write it like this first. Put this minus as a plus. So I have 1 over -5 into 1 over -7 plus 1 over 22. All right, and then we're going to multiply it now. Equals now this times this becomes 1 over 35. As a minus times minus is a plus. So 1 over 35. So it says that you must say answer must be this one. Because 1 over 35 is this or this one. One of those two. And then what happens is that the minus times this remains minus. It becomes minus 1 over 110. So that answer is A. Is it? Answer is A. But I write that.
Yes,
Very
sir.
good. All right. So for this one, now there are no limits. There must have a constant of integration, right? Constant again is a composite function of integrating. So where is it? Where gone? Here. Right here. All right. So the composite function, so it's very easy. All right. So it becomes equal to the whole thing first becomes 3x minus 5. Add 1 to the power, get to the power 5. Divide by the new power. You have to remember to divide by the differential of what's in there, which is a 3. And then you add a constant of integration. Some people put K, some people put C. It doesn't matter. They can be K or C, no matter. Plus C or plus K. Answers of K, put the K. Right, this one here says 15. So the answer and the power is 5. So this write it out, it becomes 3x minus 5 to the power of 5 over 15 plus K. Look carefully for the answers. Let them look close. So this is one of 15 and here, but this is a cube. The power must be 5. So this is the answer right here. All right, don't give it away. Finishes that. Next one. This one says if constant K is another composite, integrate this now. Easy again. Add 1 to the power, divide by new power, also divide by the 2. So it becomes equal to 2x minus 5, add 1 to this power, divide by the new power, and also divide by the differential quantity that's inside, which is a constant 2 plus the c. All right, so now here says that 8. So it's 2x minus 5 to the power of 4 over 8 plus c. So looking for that, y is 4, and you have 8 under here. All right, y is 4 and 8. So then says c again. So this is almost the same thing, right? Different values, same thing. All right, next one. More integration. This one now says, if dy by dx equals this, then the sketch of y represents what? Now the sketch y is a function, right? Y is a function. Now, if dy by dx equals this, I want to find the y, I have to integrate. So from this, you know that the function becomes the integral of 2x dx. Don't forget to put dx. Integral of 2x with respect to x. All right. So how you do this? You're gonna get add 1 to the power, so you're gonna get 2x squared. I should know that the differential of x squared is 2x, and so if you integrate 2x to get x squared. All right, let's say number now. So we're gonna get 2x squared over 2 plus a constant. So you're really getting x squared plus a constant. So I can start with the x squared graph, which is the x squared graph is this, you know. X squared graph is this. Pass right to the origin there. So that's the x squared graph. You see the plus c. The plus c means that it can be further up on the y-axis, like it slide up, or it can be down here. When you say the turning point is still on the y-axis. So this is if c is a positive, if c greater than 0. And this is if c is less than 0. Right? And this one is when the c equals 0. All right, that's the x squared graph, you know, x squared graph. The quadratic, the first quadratic graph, like the primary quadratic graph. So any one of the graph look like this, good enough. All right, so this one good enough right here. All right, that one can't be any of these other ones, no. All right, but it is the answer. So it's a quadratic graph, x squared. But the plus c means that it slide up on the x-axis or slide below, depending on whether the c is positive or negative. So I'm marking this as my answer. All right, that's it. So we'll start with the basic x squared graph and we'll just transform it basically. All right, everybody go to that? Everybody okay? I want some answers. Everybody okay?
Yes, sir.
All right. All right, let's continue. This is another, I could do this one already. This one look like I could do it already, you know. It's very familiar. No matter. That's how they start to look sometimes. All right. This one is almost the same thing. Almost the same thing. All right. So let's do it. I don't want to the power divide by new power and divide by what's in here. So you see that's the beauty of learning math, you know. When you do the same thing multiple times. The next time you see one like it in the exam, you must get it right. You do the same thing multiple times. All right. So you're gonna get 2x minus 4. Then I can integrate as if it is x cubed first. So you add 1 to the power, you get 4, divided by the new power of 4. You also divide by differential inside, which is a constant. It's a constant, which is 2. And you add a k. So now you say that 8. All right. And it's a power of 4 up here. So that's the key thing. 4, 8 on the denominator. So this is it. Easy stuff. Let's continue. This one is a similar thing, but no, they have limit. Go to this one a while ago. the same 812. Let me see. Let's see. It's the same exact question. This one, don't have to read it again. It's repeated. All right, so we don't have to do that one again. We can just copy this solution over. Copy this and paste it over here. Same exact thing. Same exact thing. All right, same exact thing. Then says same. I repeat the question. It's repeated and document. That happens sometimes. Repeated. All right. Next question.
Come on to that.
This question says, with the mic, please. This question says the region in the first quadrant enclosed by the curve y equals x minus half x squared and x equals 0, x equals 2 is rotated completely around x-axis. The volume of solid form is generated is what? All right. So remember now, getting some volume question. I don't know if you have enough space right here to do this one. Let me see if I can zoom it up. We're trying to find the volume, eh? And I want notice the answer, find it. All right. So the first thing is that volume of revolution. That's right. Formula for volume of revolution is pi times the integral of the equation of a curve squared dx between the limits. I give us a limit of 0 and 2. 0 and 2. This is a function. We'll have to square that, guys. We'll have to square that, you know. All right. So let me square it from now. We need the y squared. Let me square this from now. So the y squared means all of this squared. Remember, when you expand a perfect square, you're going to get 3 terms. First term squared, twice the product of the 2. Second term squared. You cannot integrate this as is with a square on it, you know. You can't integrate like a composite, you know. Why? Because when you differentiate the expression in here, you're going to get something with an x. Once you're getting something with an x, you can't divide by it. You can only differentiate. You can only integrate composite of the form ax plus b to the power n. That way, we divide by the a. Because when you differentiate here, now you're going to get a x. You're going to get an x. You can't divide by an x. You can't do it that way. You have to expand it out into separate terms. So we have to expand out the perfect square, the square. We have to expand out the y squared. You can integrate it like a composite as x squared. So we expand out the squared of this, the square of this. So the y squared, which we need, the y squared, which we need to put inside here, is equal to first term squared is x squared. Twice the product of the 2, multiplying this times this. What we get? We get half x cubed minus half x cubed. You double that, you're gonna get x cubed. So we're gonna subtract x cubed. That's twice the product of the 2. And then the second term squared is a plus x to the 4th power over 4. I don't know why CSEC give this in a but it's there. That's why you have to integrate now. All right. So the volume becomes pi. And we're just going to integrate this now. We're using this up here, so I'm not going to write too much thing. We're going to take this and we're going to integrate it right just now. So we're going to do the integral of this y squared now. That is why it's going to integrate. All right. Just to kind of save some space. I'm going to put it in the bracket now as if we integrate it. We integrate this, you're going to get x cubed over 3. Integrate this, you're going to get x to the 4th power over 4. We integrate this now, you're going to get x to the 5th power over 20. At the 5, we're going to come and multiply by the 4, give me 20. We're going to get x to the 5th power over 20. And you go in between the limits of 0 and 2. Now, this 0 is going to give you a 0 everywhere. So we really need to work out what the 2 is going to give us. So the volume equals pi into, we're going to plug the 2 right there, so we're going to get 8 over 3. 8 over 3 We plug the 2 here, so we get 16. 2 to the 4th power is 16. So we get minus 16 over 4. We plug the 2 right there, so we get 32. 2 to the 5th power is 32. So adding plus 32 over 20. That will be in the first bracket. And you subtract, when you plug in the 0, you get 0 over here. So I'm going to write 0 right there. So that's what we're getting. Write this square bracket better. Write the pi better. What here? And then now, I just need to put this in a calculator. And so I get, I have to, everything in terms of pi. When I work it out, I'm going to multiply by pi. So I'm just work the calculator. Just use a calculator. That's there. Right? So I'm working out 8 over 3 minus, this is actually 4, right? 16 over 4 is 4. And I'm adding 32 over 20. And let's see what I get as a fraction. I get 4 over 15. See there? 4 over 15. So it's 4 over 15 pi. So the volume equals pi times 4 over 15, which is this one, 4 over 15 pi. Voila. That's it. So you see, in this case, we have to expand out the perfect square. Square term. We have to get the y squared by squaring this and get what the y squared is. And then we integrate it. All right? That's what we did when we integrated here. So, all right, hope everybody good with that. What all right with that? What good?
Yes, sir.
All right. We'll come to this one now, another volume question. So this one says you don't have to work out anything, leave it in the integral form, right? It said the region bounded by this curve, which is y equals x squared, x-axis line, x equals 0, x equals 1, is rotated 360 about the x-axis. What is the volume? Same formula again. The volume is pi times the integral. Try it better. Volume is pi times the integral of y squared dx. You have to square this. Y squared is x to the 4th power. Right? So we can write that. From this, y squared is x to the 4th power. So integrating y squared, integrating x to the 4th power. And going between 0 and 1. So you just have to look for the right answer, integrating x to the 4th power. Between 0 and 1. So the answer is, and you have to put the pi. Don't forget the pi. Almost circle this, you know. So the pi there, don't forget the pi. Almost circle this, which is wrong, but there's no pi in front of it. So it's not the first thing you see, but concentrate. This is the answer. That is it. All right? Don't forget the pi. So using this, that becomes the answer. The volume. All right? What is that? Similar question right here. See, this time I give you a 2x squared. So what is y squared? You have a square root 2 as well. So, right? So for this one, I'm right over here. So one a space. For this one, put it in red. Y squared is gonna be 4x to the 4th power now. When you square this, it's 4x to the 4th power. So this is where we have to integrate. Using the same formula again. That volume is pi times the integral of y squared dx. Again, between 0 and 1 again. So it's almost the same question. Just change this x squared to 2x squared. So you're looking now for 4x to the 4th power. Right? So you're looking for 4x to the 4th power, and the pi must be there again. So there's no pi, so it's almost the same question. So again, the answer becomes this one. This is the answer. All right? What is that? Have a square the y. All right, so we see those similarities in those questions. This one now. This one says the diagram below shows a curve, shows a curve x squared plus y squared equals 4. It says an expression for obtaining the volume generated by rotating the boundary region she's about x-axis. So we want y squared to be the subject. So from this we make y squared the subject. So right here, so the y squared is gonna be 4 minus x squared. So we integrate y squared, really integrating this. That's what it is now. Now again, the volume is pi times the integral of y squared dx. And it's going from 0 to 2. From 0 to 2. All right, so that's what you're looking for now. And the y is this. So the y is this. The y squared is that. So you're looking for the 4 minus x squared. 4 minus x squared. This is it enough. 4 minus x squared, 0 to 2, and the pi. This is the answer. Because y squared is 4 minus x squared. So you have to square this now, because you already have y squared as a subject now. That's how it works. But go to that. But okay?
Yes, sir.
All right. This one now. This one is about area now. This one says no. The region R is enclosed by the x-axis and this curve. The line x equals 2 and x equals 3. I don't want the area. So we have to work this out. Area is the integral of y dx. Area is now the integral of just y dx. I don't have enough space to work it out here, so I'm never bring up something on the side to work it out over here. And see what the answer is. I don't have enough space to do it. Let's bring up a sheet. Clean sheet. And do it over here for you. So this area that we want would be the integral. All right, let's select a thicker. So the area will be the integral of y. This is y. So it's going to be x squared plus 2x minus 1. You know, so this is the same as x minus 1 squared. And keep it simpler. That x squared plus 2x. No, not plus. It's plus. Not plus. It's a plus. So that's going to work. Nope, that's not right. All right, so this is dx. And you're going between 2 and 3. So you have to some work to do. So you have to work out the value for the 2, work out the value for the 3. So A equals, add 1 to the power divided by the new power, I get x cubed over 3. This becomes x squared. Right? As you add 1 to the power divided by the new power, you're going to get x squared. And if you integrate 1, you're going to get x. When between the limits of 2 to 3. Plug in the 3 first. A equals, plug in the 3 first. We're going to get 3 cubed over 3. That's 9, you know, 9. That's 9. 3 squared here, so another 9. Minus 3 right here, so minus 3. Easy number, so we can just write them out. Minus, plug in the 2 now. This is 2 cubed is 8. That is 8 over 3 now. 8 over 3. Plus, this is 2 squared. 2 squared is 4. So adding 4. And we're subtracting this 2. Right? You can drop it in the calculator now, but this is 18 minus 3 is 15. This is 15. And then this is a 2 that is being subtracted. So you actually have minus 8 over 3. You minus that. And then you have minus another 2. 4 minus 2 is 2. So you minus another 2. So A equals, this becomes 13 minus 8 over 3. This 13 is the same as 39 over 3 minus 8 over 3. This becomes 31 over 3. That's this one right here. Could I just put in the calculator from right here, so still in here, so but sometimes you can work them down. Say 31 over 3. It's easy numbers. It's 3s and 2s you're working. So then you calculate that for 2s and 3, right? But that is it. That is the working out over there, guys. But all right with that? But okay with that?
Yes, sir.
All right, going between 2 here. Going between 2 here and 3 here. And answer came out to be that. All right? Next one. Similar thing again. If you integrate again. The one the area under this curve from x equals 1 to x equals 0 and 1. So same thing again. I don't have enough space. But I know it is going to become the integral from 0 to 1 of this thing dx, y dx. Right? Similar thing. Let's do it over here now again. So the y is actually this. Instead of writing minus x squared plus 2, I'm just going to write 2 minus x squared. So my area is going to become the integral between 0 and 1. This, as I said, I'm going to write it as 2 minus x squared. It's a little bit more aesthetic and friendly. So I have that negative x squared at the front there. Dx. A is going to be equal to integral of the 2 is 2x. Integral of the x squared is x cubed over 3 between the limits of 0 and 1. This 0 going to give a 0 this time. Not every time. We have to make sure. So it's really going to be the value that we get for the 1. So it's going to be 2 times the 1 in the first bracket, which is 2. And then 1 cubed is 1. So we're going to get minus a third. That's 2/3 right now, minus 0. So this is actually 1 minus a third. That's 1 2/3. That equals 1 2/3. Or I'll put another way. This 2 is same as 6. This 2 is same as 6 over 3 minus 1 over 3 equals 5 over 3. The answer is right here as well. So sometimes I wonder if it's the same question and the change of the values. That's the answer, the same. See, no matter. All right, that is it. All right, more maths equals better maths every time. Want us to get into some integral of some tricks. I think we're gonna get there shortly. Another question here. Yes, the tricks coming up now. Tricks coming up now. All right, but you see, they don't even want you to work it out, just put the correct form. So they said the region bounded by this curve y equals x 2 sine x between 0 and pi is revolve around the x-axis from a solid, right? 0 and pi. What is the volume? Same thing again. The volume is pi times the integral of y squared dx. You're going between 0 and pi. But square that, right? Y squared, let's just write it. Y squared, in this case will be 4 sine squared x. When you square this, you don't put the square in like that. You put it right here. All right, that's where when you square the sine, you put the square here, as I have done. All right, so you're integrating this, guys, with the pi. That's why you're integrating. So look for it. All right, so the 4 here. So the 4 sine squared here, and the pi is there as well. So the answer is A. We'll put this one in. All right, the answer is A. No, they could have also moved the 4 from here and put it at the front. Could have done that as well. All right, they left it there, so this is the answer. All right, then we'll come to this now. Integral of sine and cos. Concentrate and focus now, guys. Remember, when you differentiate cos, you get minus sine. So when you integrate sine, you get minus cos. Let me say it again. When you differentiate sine, you get cos. So when you integrate cos, you get sine. When you differentiate cos, you get minus sine. So when you integrate sine, you get minus cos. So when I integrate this sine, I'm going to get minus cos. So I'm going to get minus cos x. And you can check it. Okay, I'm going to differentiate this. Now I'm going to get back that. When I integrate cos, I'm going to get sine, because when I differentiate sine, I get cos. That's a multiplying constant. So I'm just going to get plus 2 sine x. And there are no limits on the integral, so I must get a plus c. We're looking for this answer. All right, just start the switch them around. This is it now. Just start the switch them around. I put this second right here and put this at the front. Right? Let me write it, which is the same as 2 sine x minus cos x plus c is the same as this answer up here. But we could have left this as the answer, but they may be trying to trick somebody and put that. But that is it.
Just get it back here plus a C on it.
All right, let's put it back there. Exactly. All right, so be careful now. Say, all right, so when I get this now, sometimes I do and double check it and differentiate back this and see if I get that, which I do. I'm going to differentiate this and see if I get back that, which I do. So when you integrate, especially sine and cos, always a good thing to double check it. Differentiate back what you got, right? Because we make mistake with the positive and the negative all the time. We're differentiating and integrating sine and cos. You have to be careful. Okay? All right. Hold on a second. Hello? All right, so ready now. When I differentiate sine, I get cos. So when I integrate this cos, I'm going to get sine. When I integrate this cos, I'm going to get sine. That's going to become sine x. When I differentiate cos, I get minus sine. That's a minus sine. You know? So when I integrate by the minus sign, I'm going to get back cos. So this negative is going to become a plus. So I'm going to get the plus 2 cos x plus c. If you're not sure, differentiate this again. When I differentiate this sign, I get this cos, which is good. When I differentiate this cos, I'm going to get the minus 2 sin x. All right? And that is it. So this is correct. So looking for that answer, which is same thing again. See, this and you know, switch it around. Switch it around to the sin x here and the 2 cos x there. Switch them around. So be mindful of these things. That is the answer. All right? Let's switch them around. So I can write this is equal to 2 cos x plus sin x plus the c. Let's switch around these two. Don't matter, the same values. All right, this one, more of the same thing, guys. More of the same thing. When I differentiate cos, I get minus sine. So if I integrate the sine, I get minus cos. So I get minus cos x. This one. If I'm not sure, I can differentiate this back. So I differentiate the cos, I get minus sine. So I differentiate minus cos, I get sine. Then when I differentiate sine, I get cos. So I integrate this cos, I get back the sine. So this negative going to come back as negative sine x plus c. I'm not sure differentiate this again. When I differentiate this cos, I get, when I differentiate cos, I get minus sine. So I differentiate minus cos, I get the sine. When I differentiate the sine x, I get the cos. So this minus not changing. So that is correct. So the answer is the last one down here. All right. Next one. I'm integrating again and I'm integrating this. So if we integrate this and then integrate that, easy. So let's write the answer down here. When we integrate this, I add 1 to the power and divide by the new power. So I'm going to get 3x cubed over 3. When we integrate cos, I'll get sine. When we differentiate sine, we get cos. So I just get plus sine x plus c. Now this is just x cubed. So this is x cubed plus sine x plus c. X cubed plus sine x plus c. Don't write this on. This is wrong. Careful with negative sign. If you're not sure, let's differentiate this again. Differentiate this again, I get back that. Let's differentiate it again. All right? If you're not sure, let's differentiate what you get. All right, that is that. Next one. This one. So if dy by dx equals that, and what is y? If we integrate, this means that y equals the integral of cos x dx. If dy by dx equals cos x, then y equals the integral of cos x. When we integrate cos, we get sine, because when we differentiate sine, we get cos. So y equals sine x. But because there are no limits, I have to put a constant of integration, which I call k. So then says A right here. Easy question. If you're not sure, differentiate this again, get back that. All right, that is it. Next one. So this one, if you notice, is about 5x, guys. So only one that has a 5x right here. So we're integrating, just like when you're differentiating, you have to also multiply by differential of expression within. When you're integrating, you have to divide by that differential. The differential of the 5x, which is a constant 5. So in addition to integrating the whole thing, you have to also divide by the differential of this, because I'm reversing the process. This 2 is a multiplying constant that can come out at the front. And so that we can just focus on here. So first thing I'm going to do is write it as, put the equal here. So I don't matter is. I'm going to first write it as the integral 2 times, we want the 2, put equal 2 times the integral 0 to pi by 2. Number pi by 2 is 90, right? I'm going to write the cos 5x dx. Ready now? When we differentiate sine, we get cos. So when we integrate cos, we get sine. But I also have to divide by the differential of this expression within. It's a composite function. So I'm going to get 2 times my limit bracket. I'm going to get sine 5x divided by 5. Pi by 2 and 0. If you're not sure, differentiate this again. If we differentiate sine 5x, what am I going to get? I have to differentiate the 5x first and get 5. Then differentiate the sine 5x, I get cos 5x. Right? And so this had to have a 5 under here. So that this have a 5 under here to give about the cos 5x that I integrated. So the integral of this is this, which is what I have here. So, see that? So we have to remember to divide by differential of that 5x as well. See, this is the only one so far that have that, guys. I can maybe write a general statement afterwards and show you. We're plugging in the pi by 2 and the thing there. And use a calculator. It's numeric. You see, the answers are numeric. Use a calculator. So this 5 can come under here as a constant. And we're plugging the pi by 2 and plug in the 0. Right? So we're gonna get 2 over 5 into, plug in the pi by 2 first. We're gonna get the sine of 5 pi by 2 minus, plug in the 0. We're gonna get the sine of 0, which is 0. You see this? This is either a 1 or a positive 1, you know, 5 pi by 2. But calculator can tell us. We don't have to worry about that right now. Right? We don't have to worry about that right now. Right? So 5 pi by 2. That's 2.5 pi. So like same as pi by 2. So gonna be 1, you know? It's gonna be 1. It's gonna be 1. Let's put in the calculator as it says 2/5. 2/5 into, I'm gonna put the sine of 5 pi by 2. Put in the calculator. You can use the calculator. So 5 pi is exactly as it is over 2. All right? Minus 0. So you get by the 2/5. They come out positive. Right? You get by the 2/5. Right? The 0.4 is 2/5. Look at a fraction. See there? 2/5 is the answer. Because this is still 1. It works out to be 1. So the answer is 2/5. All right, so that is that. right. Where are we now? Where are we? All right, here. More integration. So this one says curve C passes through this point, and the gradient of a curve is this. So give us the dy by this curve. So this is like a paper 2 question. What is the equation? So you have to integrate this then, and then use this now to find the C, constant of integration. So based on this, we know that the y is going to be equal to the integral of 7 minus x squared dx. I'm going to use this to find the C after the integrate. So it's going to become 7x minus x cubed over 3 plus a constant. That's what the y equal. Use this point in the line, in the curve now to find the C. So using 2, negative 5, meaning x equals 2, y equals negative 5. Plug them in here to find the C. Because it's a point on the curve, it satisfies the equation of the curve. So you're going to get negative 5 equals 7 times 2. 7 times, can I just write it? Probably 2 right here, so I get 14. Minus, this is 8 over 3. Plus C. So, boom, bang. So I'm going to subtract the 14 and add the 8 over 5. So the C is going to be negative 19. Negative 19 plus 8 over 3. Right? So right now these answers not looking good. This don't look right. Oh, it's a mistake here, man. This is a cube and I write square. So let me erase all this and start up. Erase just this. It's a cube, not a square. So you see, you have to pay good attention. This is a cube. So integrate it is going to become y equals 7x minus x to the 4th power instead over 4 plus c. Good. You plug in the values now. So you're going to get the negative 5 for the y right here equals 2 right here. You're going to get the 14. So is 14 minus now the 2 to the 4th power. So it's 16. 16 over 4 is 4. So I'm going to get a 4 here. So minus 4 plus c. Now this is 10. 10 go over here and become negative 10 and negative 5 with negative 15. So this means that the C equals negative 15. And so the equation becomes y equals 7x minus x to the 4th power over 4, and the C is negative 15. So looking for that answer, which is the first one. That is the first one. And so it's almost like a full paper 2 like question. All right. We'll come to this one now. We want us to differentiate this as a differential again. Oh, sorry. They say, given that the differential of this is this, so give us that, right? They're asking us for the integral of this. So basically, we have to compare this with this. No. All that is that means that this has a 3 up on here. Remember that the 3 can come out here as a multiplying constant. And then when we move over the 3, you're going to end up back with this. So what will happen is that this now will become equal to, let me write over here. It's going to become equal to, that's this integral, I put it back in blue. Equal to this integral, move the 3 out here. I'm trying to get back that expression. So I'm going to put the 3 times the integral from 0 to 2 of 1 over 1 plus x squared dx. And then now, if the differential of this is this, then it means that the integral of this, when you integrate this, you're going to get back that. Right? If when you differentiate this, you get this. then it means that when you integrate this, you're going to get back that. So right now, because they told us that the differential was this, we now know that the integral of this is this. So we know the result for this. The result for this integral is this. Okay? So we have to integrate it ourselves. They told us, I'm going to put a 3, put back the limit brackets, and then now the integral of this thing in here is the x over 1 plus x. And going between 2 and 0. That's what they work it out. The 0 going to give you a 0 this time, because you're going to put the 0, they're going to get 0. So it's really what the 2 give us is the answer. So it's going to be 3 into, plug in the 2 first, we're going to get 2 over 3. You can put 2 years and 2 years, so I'm going to get 2 over 3. Minus, plug in the 0, I'm going to get 0. So the answer is 2. 3 times 2/3 is 2. So it comes all the way down to a simple 2. That question there. Nice and easy like that. All right. But I wanted to write a general statement for the integral of the sine and the cos when you have a value. Let me just write it here. So for you. Let me just write it here. So draw a line and write it. Because I was I wanted to write it. So if you integrate sine AX, some value x with respect to x, you're gonna get, you have to divide by the a now. When you integrate sine, you're gonna get minus cos, because we differentiate cos, you get minus sine, so you're gonna get minus cos AX over a plus your constant. And if you integrate cos a times x with respect to x, when you differentiate sine, you get cos. So if you integrate cos, you're going to get sine. So I'm going to get just a sine AX divided by the a plus c. And to double check it, you can differentiate this back. When you differentiate this, you're going to have to multiply by the a now. So that you're going to cancel back this a. Same thing up here. So those are your general integral, not just x. Right? AX, I will remember to divide by the a. So for example, 5x right or so, you're going to divide by 5. And then 6x right or so, you divide by the 6. Right? If you get stuff like that. All right, so that is that. Moving right along. So basically finish the thing, like take another short break and then come back. So this really finishes the integration. Can we just go straight into the probability afterwards, Statistics, not a lot of questions. Statistics and probability, right? Yes. All right. And then we'll go and see what is what. All right, so integrating this now. This one have a limit, so we just have to work it out. So firstly, what does it become? All right, so we're gonna put limit brackets. Just have to work it out. 1 and 2. Integral of x is 1. Integral of x is x squared over 2. Integral of x squared is x squared over 3. X cubed over 3. Between the limits of 1 to 2. You're gonna plug in the 1 and then plug in the 2. And plug in the 2 first and then subtract what you get and plug in the 1. So it's gonna be equal. Plug in the 2 first. You're gonna get 1 plus this is gonna be 4 over 2, which is 2. Plus this is gonna be 8 over 3. 2 cubed is 8 over 3. Minus plug in the 1 now. You plug in the 1, you're gonna get 1 here, so still. It's gonna become a half. And it's gonna become a third. That's what they're working out, And drop that in the calculator. I can work it out. This is 3. 3 is the same as 9 over 3. 9 and 8 is 17. So it becomes 17 over 3. Minus this now. Put everything over 6 in the bracket. Alright? This becomes 6 over 6. This becomes 3 over 6. and this becomes 2 over 6. Everything over 6. Can I put this over 6 too? 1 is by 2, 1 is by 2. A 34. So it's 34 over 6 minus. What is work out to? It says 9 and 2 is 11. 11 over 6. Works down to be 23. Yeah. 23 over 6. 23 over 6. What you get? 6 4 is 24. That's right. It's not right. This doesn't look right. I'm gonna get a full 4. It's not right. Make a mistake somewhere. 2, 1. It's don't look right. 24 over 6. I don't want to say I'm right. That's 6 4 is 24. So it can be this. 6 4 is full 24. I'm saying all right. These answers are not correct. I'm just double check it. Let's just double check. All right. So integral of, oh, I see the mistake. See, integral of 1 is x. Jesus. Integral of 1 is x. So this is supposed to be x. Integral of 1 is x. So this is gonna be a 2. Zoom it up. This is gonna be a 2. I'm putting a 2. This is gonna be a 2 plus 2. And this is gonna stay a 1. It's gonna stay a 1. I'm putting in the 1, right? So this is going to change. This is going to change. It's going to become a 4. And 4 is same as 12 over 4, 12 over 3. And 12 and 8 is 20. So it's a 20 over 3. 20 over 3. So it becomes 20 over 3. 20 over 3 or 40 over 6. And then 40 minus 11, 39. 40 minus 10 is 30, 29. So this is the answer. Yeah. Because 6 4 is 24. So you get 4, remainder of 5. Yeah, that is the answer. That's better. So make a mistake. Don't give it away because the wrong answer was the other mark and gone. I didn't realize this mistake. But that's what it is. Mistakes are made sometimes. All right. Fortunately for these exams, the answers are on the paper. So if you make a mistake, you're able to catch yourself. All right, so we're going to take a little short break and then we'll come back and run the probability. All right, probability and statistics. And then maybe we can go back and do something else here. So based on the time now, like we're definitely going to have the session tomorrow now, unless you guys want to continue. As I said, the time that I set originally was to finish in the next half an hour. Yes, we did start late, but a lot of persons came on late. But if you want, I can continue this afternoon, right? If you want, all right? So that, you know, we have less work to do tomorrow, or if we can clear it off and don't have anything to do tomorrow. But we still have a number of things to go through. I don't think I did any of these with you today. I did the differentiation today. So there's some stuff on here that is actually marked that I did not do with you. I was doing it with somebody else before this class, like these. We did this today. Yeah, we did this summation today. All right. We did this today. Series. Okay, so that's why these are marked. We did this sequence and series before. That was the first thing that we did. Sequence and series. So those are marked. We did these already. All right, so we have the logs, we have the vectors, we have the inequalities. We have a number of things to do. So it looks like we're definitely gonna need tomorrow unless you guys prepared to do it today. It all depends. You know, if you want to do it today, because the flyer said until you say when. So if you want to continue working and just finish all of them today, so that you just watch over the video and have all of them worked out, then fine. I mean, a lot of questions, but it's a good set of questions. You know, where to cover all the bases. So we have the coordinate geometry, the vectors, right? We have circular measures, and then we have trees, right? We have trees as well. So all of these things. Then we have motion as straight line. We have a couple questions on motion as straight line. Not a lot. We have a couple questions on motion as straight line. Well, let us take a 10 minutes break now, and we'll come back and do the statistics, probability statistics here. Since it's just right here, we can come back and just do that. Maybe what we can do afterwards is find the motion as straight line questions right here. They come after the tricks. Not a lot of them, you know, just a few. Just a few. We'll go 4 questions. 1, 2, 3, 4. Right. So, all right. Let's put up a 10 minutes break. Come back and do this here. All right. Well, cool with that. Cool with that. I prefer to do a different topic. If you prefer a different topic, you can tell me, you know. If you figure say you're good with this topic, probability statistics, and you want to do a different topic, fine. I mean, you know, I like to finish all of them with you. It all depends. So you can let me know. Let me take a break. Put the timer. Take a 10 minutes break. So we're gonna go past 4 o'clock a little bit. But because that's one topic, we might not go too far. I remember I did start late. If we join late, I did start late. All right, take a 10 minutes break. All right, guys. Ready again? We got an extra minute. All right. Hold on a second. All right. So let us continue. Hold on a second. Hold on 1 second. In life, okay, it's there. All right. All right. So we're gonna do some of the statistics questions. All right. Remember, the recent topic on the multiple choice statistics and probability. I think they only started in 2021. 12 these on the multiple choice. All right. Anyway, so let's go. Everybody there with me? Can I see the screen? Can you hear me? Or just let me know, please. Students, can you hear me? Can I see the screen? I don't want to be working on, you're not hearing me and not seeing.
Yeah.
All right, good. Well, thanks for that. All right, so let's go. Probability statistics. This first question says, the following probability table shows the probability of a biased spinner landing on 3 of 5 possible prizes. So these are the prizes. These are the probability of getting the prizes, and they only give us 3 of them. They said if winning a car or a cruise vacation are equally likely, so these two have the same probability. What is the probability of winning a car? Well, you know that the total probability must be 1. And so the sum of these two must complete the total to be 1. All right? That's what we know. So what is each of them? And they said that they are both equal. So basically, once you find the total that these two must be, you divide it by 2, and that's the probability for each of them. All right. So it's basically the total must be 1. Total probability is always 1. All right. So the total must be 1. We can work it down. This is half already, and this is 0.4. Right? So if this is half and this is 0.4, these two must be 0.1. These two must add to 0.1. These two. This is half. These two are 0. So if this is half, then everything here so must be half. And down here, so it's 0.4. This and this is 0.4 now. 0.25 and 0.15 is 0.4. So these two must be 0.1. These two must add up to 0.1. So we mark it. These two must be 0.1. We mark it. So this must add up to 1. Right? These add up to 0.9. So these must add up to 0.1. And if they are equal, then each of them is half of 0.1, which is 0.05. And 0.05. So the probability of getting a car is 0.05. That is it. Same way, the probability of getting a cruise vacation is also 0.05. All right, so that is that. Easy question. Next one says, in a regular deck of 52 cards, where there are 26 red and 26 black, so half and half. If a card If a single card is selected at random, what is the probability that it is red? Must be half. Half of them is red. So it's 26 out of the 52, which is a half. 0.5 is the probability. All right? Half of the card, half of them will be red. So the probability of getting a red is half. Next one. A fair die. A fair-sided die is rolled. Given that an odd number has turned up, what is the probability that it is prime? All right, so a fair die. So we assume a die has 6 sides, right? 6 sides. So basically, is how many prime numbers? What is the probability given that an odd number? And so it's how many prime numbers are there in the odd numbers? That's what it's asking, you know. Given that an odd number turned up, what is the probability that it is prime? So in other words, how many prime numbers are there in the odd numbers? So if you list the numbers that you can get, 1, 2, 3, 4, 5, 6. First, you want the odd number. You want the odd number. So the odd numbers, taking out the odd numbers, is the 1, 3, I left out the 5. 1, 2, 3, 4, 5, 6. All right, so it's 1, 3, and 5. All right, 1, 3, and 5. So out of that 1, 3, and 5, 1, 3, 5 are your odd numbers. You want a prime one out of it. So these are the 2 prime ones. So probability is 2 out of 3. I'm getting a prime number that is odd. Prime number out of the odd. So it's 2 out of 3. So then says this. But let's say I want to bring it down to the basic theory. This is a simple way, you know. Of all the odd numbers, what's the probability of getting a prime? So it's 2 out of the 3. So it's 2/3. We could also set it up as a Venn diagram. Right? You can set up a Venn diagram, you know. Let's set up a Venn diagram and represent it another way and do the probability. All right? So we can understand what is that. So if we draw a Venn diagram, I'm going to put on a Venn diagram our odd numbers and our prime numbers on a Venn diagram. So put in the odd numbers and the prime numbers. All right. So firstly, if we were to list the odd numbers and also list the prime numbers separately, let's remove this. I'll leave that. Let's leave that. Let's leave this. If these are my odd numbers, right? I'm going to put my prime numbers now. The prime number, remember, 1 is not a prime number. So the prime numbers will be 2, 3, and 5. That's why I get the same 2 right here. So the intersection of the odd and the prime is 3, 5. 3, 5. So I'm going to move this circle and put it a little bit wider. I'm going to put the 3 and 5 in here in the intersection. And then after odd numbers, we only have 1 left. And the prime numbers, we only have 2 left. And then the numbers to complete it are these 2 other even numbers. 4, 6. So that 2 is a prime number. 2 is the only prime even number. So those are your 6 numbers. 1, 2, 3, 4, 5, 6, right? So this question is basically asking you this question, you know. It's asking you, given that an odd number turns up, what's the probability that it is prime? So the probability of getting a prime number out of your odd numbers. So it's how much of the intersection is inside of O. So that's why it is 2 out of 3. 2 out of 3. So it's the probability of getting what is in the intersection. Right? How much of the intersection is inside? Another way of saying it, you know, is this. Another way of saying it is this. It's the probability of getting a prime number, the probability of getting a prime number given that it is odd. it is equal to the probability of the intersection, prime and odd, over the probability that is odd. What's the intersection? The intersection is really 2 out of 6. And if you look on the entire set now, intersection is 2 over 6. You know? So this is 2 over 6. Oh, wow, what did I do? Right? The intersection really is 2 over 6. So this is actually 2 out of 6 in the intersection is 2 out of 6. 2 out of 6. And down here, probability of odd is 3 out of 6 or half. Right? On here is 3 out of 6. So if you divide these, 2 over 6 over 3 over 6 is the same as 2 over 6 times 6 over 3. These cancel, you still gonna get 2/3. So anyway, look at it, it is 2/3. All right. So hope you understand that. Any questions on that? There is a formula method, or just a reasoning that is how much prime number are there in your odd numbers. So these are the prime, 2 prime, 2 out of 3. These are your prime numbers that are inside your odd numbers. All right. All right. What is that? All right, next question. The next question gives us this stem and leaf diagram, two-sided. All right. So these are for the boys, these are for the girls. Reading the girls this way. So for example, this is 26, no, 36. This is 36. And reading this way. So for example, this is 38. All right, that's what it says. It said the following stem and leaf plot shows the mass to the nearest kilogram of a grade 6 class. So you have the boys on this side, and the girls on this side. As I look at it, I can say the boys' distribution is symmetrical, nice and symmetrical. And the girls' side is skewed, right? Because you have anything here heavy up here, so and it gets lighter in terms of the number of persons. So it's kind of skewed, whether it's positively skewed or negatively skewed, but clearly the boy is symmetrical, right? It said, which of the following statement is true regarding the shape of the distribution of the weight of the girls and compared to the boys? He said the weight of the boys and girls are positively skewed. No, this is not true because the boys is symmetrical, obviously. Okay, if you divide up this half and half, it's symmetrical. Right? Symmetrical. Right? Hey, remember the median and so on is a position thing, you know. This is where the values are, a position thing. So the position of the median is halfway of the distribution. And the first quartile is 1/4 of the distribution. And upper quartile is the third quarter of the distribution. So based on how this is set out, then you know it's gonna be symmetrical. The boy is symmetrical. So any answer we say the boy is not symmetrical. No. It said the weight of the boys and the girls are relative. It's not true. The girls are symmetrical. I see every down here so on the low values and then they get right up here. Right? Next one says the weight of the girls are negatively skewed while the weight of the boys are positively skewed. This is untrue as well. Again, the weight of the boys is not positively skewed. The next one says the weight of the girls are positively skewed while the weight of the boys are symmetrical. This is the answer. Right? The girls weight positively skewed and the boys weight symmetrical. That is it. Because what means that the values stretch out to the right on the girls' side. They have less figures. It's more you have more persons closer together within this range, and then kind of stretch out. You'll have one person out of 53 is gonna stretch out to the right. And if you do a box and whisker plot for this, you see that it stretch out more to the right. All right, that's what you'll find. You do a box and whisker plot. So this is the correct answer. Girls, the boys clearly symmetrical and the girls positively skewed. All right. Next one. Joseph collected data on the colors and the color of cars passing his yard. The data can be described as qualitative, discrete. What is qualitative? Qualitative is like I saying how red something is, how sweet something is, how dark something is. That's qualitative. Right? Discrete is when you're counting data that you count. Hold on a second. Hold on a second. Hello? Yeah? I'm in a class. Huh? Yeah. Jimmy was calling me first, but it's all right. I was just trying to call about Jimmy. But it's all right. Cool. No, I'm in a class now. Yeah, man. Cool. Yes, guys. Sorry about that. Right. Then discrete data now is discrete data that you obtain by counting. All right. Data that you obtain by counting. So which of these is the correct answer? Quantitative. Continuous is measurement. So we're not measuring anything. So this one out of it and this one out of it. We're not measuring anything. So I think this is the correct answer. Quantitative and discrete counting data. Right? It's basically getting the color of the cars. No, that's qualitative. Joseph collected data on the color of cars passing his yard. The data can be described as. All right, so I say quantitative and discrete. Because it's gonna count the number of cars. Or qualitative because you want to say whether red or blue. So I'll say this is the answer A. And so these three. Qualitative. Okay, you want to know the color of a car. Red, blue, that's qualitative. And discrete is counting. Continuous is measurement. You're not measuring anything. You're just gonna say red car, blue car. This one is redder than that one, color of the cars. So qualitative and discrete. You have to count them. 5 red cars, 2 blue cars. Right? That's a discrete data, counting data. Continuous data is measurement. So those two clearly out of it. All right, next question. It says there are 108 cards in a deck of Uno playing cards. Don't even know what that is. It said there are 4 wild draw 4. So this is one type of card, 4 of that one. 4 wild draw 4 of that one as well. That's the name of this kind of card. So that's 8 of R. And then 25 each of 4 colored cards. There's 4 of them. So where you go, the 25 times 4 make 100. Then the 4 of this one and 4 of this one, the 108. All right, good. All right, so the colored cards is 100. If a player needs to select one card, what is the probability of not drawing a wild 4 card? You don't want the wild 4 cards, only 4 of them there. The wild 4 cards, there are 4 of them. You don't want one of them. So it means you want one of the others. And there are 108 cards remaining. 108. So it's 108. No, 104. So the probability of not getting one of these is 104 out of the total 108. That's what they're working out. Because there are 4 wild draw 4 cards. There are 4 of them here. Total cards is 108. So it means that you want one of the 104 cards remaining. That's what you want, one of these. That's the probability. All right, and we can just switch one of these works down nicely. Looks like it's gonna be this one, based on the numbers. Let's just see. What do I 2 by 4? Let's just put it in the calculator and see what it says. 104 over 108. Let's see what it says. See, 26 over 27. Yep. 26 over 27. So this is the answer. All right. You don't want one of the wild 4 cards. So wild draw 4 cards. So you want one of the one of the 104 cards remaining. That's it. Next question. This is box and whisker plot. Let me show it vertically. It said the following diagram shows a box and whisker plot for the height of male and female students in a physics class. So the dark one are for the males and the unshaded ones are for the females. All right, which are the following values describes the range of height of the class, of the entire class? So it's everybody I want. So remember, the highest value would be up here. As the highest height of anybody happens to be a boy. And the shortest person in the class would be a girl down here. So the range is different between those two values. That's the range of the class. They wanted the range of the boys, then to be from here to here. That to be the range for the boys. They wanted the range for the girls to be from here to here. But they want the range for the class to include everybody. So the range is all the way up here. Let's see what this is on this line. And come all the way back down to the shortest girl down here. That's the range of the height of a class. All right, up here says, let me say every line is 1, because this is 160, 5, 66, 67, 68, 69, 70. So every line is 1. So therefore, this is actually 173. And this is 155. And this is the range. So the range becomes 173 minus 155, whatever that is. 173 minus 155, 173 minus 155, 18. 18 is the range. Right here. So 173 centimeters minus 155 centimeters, which is 18 centimeters. The tallest person in the class. So if we give back the same question, let's say the tallest boy, at the range of the boys, then it's just here to here, as I said. All right, so I could give back the same information and ask different stuff. All right, but that is it. Next question says, the following table shows the performance of final year university students majoring in social work or psychology on a research project. And they didn't complete the table, right? So these are the totals. We can fill it out. These are up to 500. This is 500 pass. So these are just the passes, right? 500. And this is 40 failed. So it means that you have a total of 540. 540. If you add up these, you're going to get 215. And if you add up these, you're going to get 325. So the social work is 215. The psychology is 225, but the total of everybody is 540. So you can ask a question about the social work. You can ask a question about the psychology. But you can also ask a question about everything. You can ask a question about the pass. You can ask a question about the fail. So you have to just read the question and see what they ask. It's a probability expressed to 2 decimal places of selecting a student who failed as a student, and but tell you whether it's psychology or social work. So the total students is 540, and the total who failed is 40. So the probability of getting one of those is 40 out of the 540. That's what you want. 40 over 540, which is 4 over 54. And so to the 2 decimal places, so it's this one. Because we're getting 0.7, 0.074 repeated. The line on top there means repeated. So to 2 decimal places is 0.07. So this is the answer right here. So to 2 decimal places, right? That's it. All right, nice and easy. All right, so finishing off these questions fairly quickly. They're done. The next one gives us this Venn diagram, and it says there are 120 students in a school's music club. The Venn diagram shows the probability that a randomly selected student plays a piano or the guitar. So the piano is set N, the guitar is set G. So these are the probabilities. Remember, the total probability must be 1. So if you add up these, the X is out here, don't play piano nor guitar. They must add up to 1. All right. So they're asking us for the value of X. So X is going to be equal to 1 minus the sum of these. Because 1 minus 0.4 and the 0.35. Shift this over. And the 0.15. All right, that looks like 0.1. These two is 0.5. That's 0.4. So this is 0.1. And this is the answer. All right. That is that. Next one says, what is P probability of getting N given that G has occurred? All right, getting a student to play the piano given that he played guitar. So basically, it's how much of N is in G, right? That's what it's asking us. So this is basically asking us this question. How much of this is inside of all of this? That's what it's asking, The amount of N that is in G. The amount of N that is in G is 0.35 out of 0.5. That's gonna be the answer. How much of N is in G? So it's gonna be equal. If you write as a formula, it becomes the probability of the intersection N intersect G, which is the same value in here, over the probability of G. The probability of G is all of G. Anyway, take it together, 0.35 over all of G, which is 0.35 plus 0.15, which is 0.5. So 0.35 over 0.5. To divide by a half is to multiply by 2, so it's 0.7. That's 0.7 right here. That is it. All right. Some other statistics questions, If I do have about the class tomorrow, I think we can maybe look at those. There's some other statistics questions about mutually exclusive events. For example, events that are mutually exclusive. For example, if A and B are mutually exclusive, like it means that they don't intersect at all, A and B. And they are mutually exclusive if the probability of A intersect B is equal to 0. A intersect B happens to be 0, then A and B are mutually exclusive. And then we have independent events. So this is mutually exclusive. Mutually exclusive events, right? There's no intersection. Then we have independent events and conditions for independent events. Independent events. Independent events is one where the occurrence of one does not depend on the other. The two ways they can prove independent events. So the conditional probability, for example, probability of A, given that B has occurred, will still be equal to the probability of A. That's one way. Right? The other way is if the probability of A intersect B is equal to the probability of A times the probability of B. Any of those two things you have happening, it means that you have independent events. So if we get a question, talk about independent events, This basically what you're looking for, one of those two things. With a question for mutually exclusive events, and this is what is that? There's no intersection. All right? Kind of feel like CXC would want to set distance on these things. But I finished the probability on this sheet. But if I do another session tomorrow, I search for some more probability questions to bring along. All right, but that finishes this part of it. So which topic do we go on to next? Which topic do we go on to next, guys? Anybody have any preference? Anybody have any preference? We didn't differentiate this one. Didn't we differentiate this one? But oh, come and skip over this one. Oh, come and skip over this one to differentiate this one. Let's just do it now. Don't understand. I'll skip over that one. But this is the same as y equals 5 minus x to the half. So dy by dx would be multiplied by the power. You get half of 5 minus x to the minus half. But you have to also multiply by the differential of what's inside the bracket, which this time is going to be a -1. And so it will come a -1 on the numerator. Out of that -1, this 2 is going on the denominator. This minus half, this minus 4 means that I'm also going under here. And I'm going to do the half power, which is square root. So there's a square root. The 2 is under here. And then I'm going to do the square root of 5 minus x. That will be the answer, which happens to be this one. Don't forget the 2. So more left out that question. I don't know why, but so I go. Just to catch it now. Yes, I was saying, anybody have any preference? Which topic they want to do? Oh, all right. Let us do the motion and straight line question, please. There's not a lot of them right here. All right, not a lot of questions. Motion and straight line. All right, they come up in the differentiation part and the integration part. So this is one. It says the following graph represents the position as a function of time. So this is basically displacement against time, right? For a moving object. All right. It says which of the following statement is true? All right, which of the following statement is true? So this represents a graph. All right, and if you notice, it's accelerating uniformly. No, not accelerating, because it's a distance time graph. So it's a speed, constant speed. Constant speed. That's what you can know from this. Constant speed. So constant speed. I don't know what constant speed, because a constant gradient. Constant gradient. Straight line. Therefore, you have a constant speed. Or uniform speed. All right. So once you have a constant gradient, or constant speed, that's what you can get from a displacement time graph. Gradient is gradient and a displacement time graph is speed or velocity. So the object stays at rest. No, that is not true. It moves. Because now for it to change the distance, it must move, right? If it was remaining at rest, the distance or the position would be 0 to stay where it is all the time. It said the object increases velocity. No, the object never increases velocity. This is not true. Because there's a constant velocity, constant speed. It's not true. The object decreases velocity. Also, that is not true. Right? This means that increases velocity. No, the velocity is constant. The object velocity stays unchanged. The answer is this one. The last one. Simple because of a constant gradient. Gradient on a velocity time graph. Gradient on a displacement time graph is velocity. All right, so that is it. The velocity stays unchanged. Constant gradient means constant speed or constant velocity. Let me change the word speed to velocity. Velocity. Simple as that. Next one. A car and a delivery truck both start from rest and accelerate at the same rate. However, the car accelerates for twice the amount of time as a truck. What is the traveled distance of the car compared to the truck? All right. So both of them start from rest. Now, I'm going to use a formula to help us, right? They're asking us what is the distance. So we can use the distance formula. Remember, once it is accelerating, you can't use P equal distance over time anymore because the equations of motion. All right, so this question talks about the acceleration. They have the same acceleration, but they also talk about the time of acceleration, twice the amount of time. So we need a formula that has the acceleration and the time in it, which is S equals UT plus half AT squared. This you're squaring the time, guys, are squaring the time. Now the initial velocity is 0 because both of them start from rest. So therefore the S, the U equals 0 because it start from rest. So basically then the formula is simply S equals half AT squared. All right. So that's what's going to give us the distance, right? It says, however, the car, so we can do one for the car and one for the truck. Now let's say this is the time for the car. All right? This is one for the truck. T for truck. It says, however, the car accelerates by twice the amount of time as the truck. So it means that the car distance is half A. This is the time for the truck. Then the time for the car is twice that, 2t squared. So because you're squaring the 2, you're going to get 4 times. Everybody can say that. The time for the truck, if the time for the truck is t, then the time for the car is 2t, because that's it twice, and you're squaring the 2t. This becomes the time for the truck. That results in you getting the distance traveled by the car being half A times t squared, and you're multiplying by this 4 times 4. By the force, the 2 squared is 4. So it's 4 times it, 4 times. It goes 4 times the distance times 4. So 4 times as much is the answer. What is the travel distance of a car compared to the truck? 4 times as much. All right, we'll see that because you're squaring the t. So if you do twice as much, when you square the 2, you're going to get 4 times. 2 squared is 4. All right. This question, I remember this question. I think it had the wrong answer here. But the source of this question, I think it had the wrong answer here. I can know it has the wrong answer here. It says, at a stopping point on a runway, an airplane is stationary before takeoff. So that means that its initial velocity is 0. If it's stationary, its initial velocity is 0. So it is at this 10 meter stopping point on a runway. So it's basically like you leave the gate. This is the gate on the runway, and you come the taxi off the gate and it stops 10 meters. This is the plane. And it's gonna go on the runway now, it's gonna take off somewhere here. Gonna take off. Right here, so the velocity is 0. It says if the plane travels 120 meters from this point, so it travels 120 meters from this point in 4 seconds, take 4 seconds. What is the speed at takeoff? So what it's saying is gonna take off. What is if the plane travels 120 meters from this point in 4 seconds, what is the speed at the point of takeoff? So the question is, where is the point of takeoff? And we're assuming that the point of takeoff is 120 meters. It's an information. All right? It's an information. We have to assume that the point of takeoff is at 120 meters. It says at 10-meter stopping point on a runway, an airplane is stationary, meaning velocity is 0 before takeoff. All right. If the plane travels 120 meters from this point in 4 seconds, what is its speed at the point of takeoff? So when it take off, assuming that it's taking off 120 meters, we're not assuming that they're going to go any further. We assume that information is what they gave us here. So it travels 120 meters in 4 seconds with an initial velocity of 0, must accelerate, right? And we're trying to find the final velocity down here. It must accelerate. And this is the time. So this is the distance we travel. This is the time that it took. And the question is, what is that velocity at takeoff? Now, because it has an acceleration, we don't know the acceleration, and you don't need the acceleration. There is always an equation of motion that you can use. All right? There are 3 equations of motion that they'll give you an exam paper, but there are actually about 5 equations of motion that are pretty useful. And I can write them out for you. Let me see if I can zoom up and write them out somewhere. I don't have enough space to write for this question. But let me see if I can list them out here for you. Which are pretty very good for you to know. All right, so the ones that they will give you is V equals U plus AT. So for this question, we don't say the U is 0, you know, but we don't know the A. All right, we know the time, you know. We're trying to find a velocity, but because we don't know the A, we don't want to be using that one. Another one that they give you is that S equals UT plus half AT squared. That's the displacement one. Again, this is equal to 0. But again, we don't know the A, we know the time, we don't know the A. We also know the distance. So this can actually help us to find the A, you know. I will know the distance, I will know the time, I will know the U. So we can find the A. But there's always one that you can use based on the information that you have. Because they are all derived by substituting from each other. All right? Another one is that S equals VT minus half AT squared. Now, this is one that you're not going to see a lot. It's also very useful. And you get that one if you were to substitute for this V in this formula. Substitute for the U, I mean, in this formula. Right? You're going to get this one instead if you substitute. All right? And then another one that you can have is that displacement is average of velocity, which is U plus V times time. That one, nice, I don't have the velocity. You don't have the acceleration in it. So notice everything so far have the acceleration. This one don't have acceleration in it. And this question, we don't know the acceleration. That's a good one to have. And how do you get this one? If you use these two and add them, if you add these two together, you're going to end up with that one because it will eliminate for us this part of it, the A. All right? And you're going to end up with this. You can try it if you want. This is one that they don't put on the exam paper. So I'm going to mark the one that they don't put on the exam formula sheet. They don't put this one on the formula sheet. They don't put this one on the formula sheet. This one is there. This one is there. And there's a third one that is on the formula sheet, which is the 5th one that I'm going to write, which is V squared equals U squared plus 2AS. This one do have the time in it. So this one is also on the formula sheet. So the two with the asterisk are not on the formula sheet, but they are very good to know. And so this one is if you don't know the initial velocity, you can use that one. This one knows when you don't know the acceleration. So because we don't know the acceleration, we know the distance, we know the initial velocity is 0, we know the time, and we want the V. So this is the one to use for this question. See, but if you don't know it, you can use it. You have to find the A first and then proceed. So this is a very good one now to use. So we're going to use this one. Remember, the initial velocity is 0. You know? We're trying to find the velocity, final velocity V. All right. So I'm going to use that one right over here. So I'm going to use it right here. So now. So if I plug in the values that I know the distance is 120 equals half. The initial velocity is 0 plus v, the final velocity I'm trying to find, and the time is 4 seconds. That's it, you know. Time is 4 seconds. So if I work this out, I'm gonna get v equals 60 because half of this 4 is 2. 2 divided on you give me 60. So the velocity is 60. I guarantee you that this is the correct answer. But it's not here. No. If you go and you do speed equal distance over time, and you do this divided by this, 120 over 4, you're gonna get 30. And 30 is there. But that can't be right. Why? Because speed is only equal to distance over time when there's no acceleration. And you must have acceleration if you're going to increase the speed from 0 to another speed. You must have acceleration. Once the speed changes or increases, there must be acceleration. Acceleration is not 0. Speed equals distance over time only when the acceleration is 0. Speed equals distance over time. Right? Only when the acceleration is 0. All right, so we have to remember that. So this is my answer, guys, but it's not there. I'm saying 60 meters per second. Right? And this is not the correct answer. Cannot be. Because there must be acceleration. So you can't use speed equal distance over time. So let's set a question like this again. This is the correct working out for it. Remember this formula. More than likely, for a question like this again, they will have the correct answer. All right, so that is that. Next question. Given an expression for the acceleration, given an expression for the acceleration of a moving object, the velocity of the object can be found by, so remember now, this is just testing your knowledge of the rate of change, and how you go up the hierarchy of the rate of change. So what it is that if you have displacement, if you have a formula for displacement, you have to differentiate it to get velocity, and you differentiate the velocity to get acceleration. You go up the hierarchy by differentiating. And then when you want to go back down, you do the reverse. You integrate. To go from acceleration back to velocity, you integrate, and to go from velocity back to displacement, you integrate again. So in this question, what it is that we have the acceleration and we want the velocity. So we have to go, we're going here. So we have to integrate. So we integrate the expression. That's what it is. Integrate. All right. What is that? This is differentiate. Differentiate when you're going up the hierarchy, displacement to velocity to acceleration. Integrate when you're going down, acceleration to velocity to displacement. This is displacement. All right, and I think that finishes these straight line motion questions. Only 3 of them right here. That is it. All right, any preference for the topics next? Any preference? Still no preference? All right, no preference. Let's see. All right, let's go and do back in module 1. I think I'm gonna do one more topic, and then we're gonna just call it a day, as no 4:30, 5:30 thing. And then we'll pick up back tomorrow and try to finish off the thing. All right. Finish stuff tomorrow. This is surge logs and indices. Trying to do an easy topic just to finish off. Maybe there's some inequalities here. I'm going to do some inequalities here. And I will finish off for the day. All right. Yeah. We're not going to do the functions question straight. We're not going to do the functions. The function no longer on the syllabus. That topic. So we're just going to do these inequality questions here. Nice and easy. These are linear inequalities. So you're basically trying to make x the subject, right? That's what you solve. Remember, for inequality, you have to multiply or divide with a negative number. You have to remember the reverse inequality sign. So I can decide, for example, to group x terms on this side, right? Transpose, normal transposing. I'm just put it on this side. So I'm gonna do it two ways. Let's divide the page and do it two ways. So I'm gonna transpose and put everything on this side. So I would get 5x minus 10x greater than, then this will be negative 13, negative 7. Right? Let me shift this over a bit. Right? It will be negative 13 minus 7. This will be, this is 10x in a month. Jeez, double space. Let me go again. Right. So 5x minus 10x greater than negative 13 minus 7. Then this becomes negative 5x. So it's minus 5x greater than negative 20. Now, 20 people would just, all right, let me divide through by negative 5. Right? Some people would just, all right, let me divide through by negative 5. I don't want that, man. Why give me that? Undo. Right, so let me divide by negative 5, divide by negative 5. We can't do that with an inequality. When you divide an inequality with a negative number, you have to reverse inequality sign. You have to remember that. So if I want to divide with a negative 5, write it out. Divide by a negative 5. I have to remember to reverse that greater than sign. Once you multiply or divide an inequality with a negative number, you have to reverse inequality sign for it to remain true. Quick example. If, for example, 2 is greater than 0, if I multiply it by a negative 1, this becomes a negative 2. This over here stays 0. For it to remain true, the sign has to be reversed. Because negative 2 indeed is less than 0. So for it to remain true, I have to reverse the inequality sign because I'm multiplying the negative number. All right? So that's an easy little proof that it has to be done for the inequality to remain true. So when we divide by the negative 5 now, this side becomes x. The sign is reversed. And this side becomes 4. That is the answer. X less than 4. But what if we do it another way? We'll group the x term on the right side. So we're going to take this over onto this side. How would it proceed? So this is an OR method. So what would happen is that we would bring the 13 over here and get 13 plus 7. Sign is greater than, I would have 10x minus 5x. Then this will become 20 greater than, this will be 5x. Then I have to divide by 5. Because I'm dividing with a positive number, I don't have to reverse the sign. I leave the sign as it is. Now I divide by the 5. This divided by the 5 is 4. The sign is still greater than, this becomes an x. So we'll be saying 4 is greater than x. But that is the same as, you can read it this way, and it would still mean that x is less than 4, which is the answer. All right? I put in x as a subject of the inequality. But that is it, guys. Nice and easy. There's another one here, very similar. Very similar. But this one's straightforward because we can transpose this over here. And if we transpose over there, we're going to get 3x minus x greater than minus 2, and carry over this 2 and get minus 2 again. So it will be 2x greater than minus 4 I'll divide both sides by 2. There's no need to reverse the sign now. We divide 2 by a positive 2. Then we just simply get x greater than negative 2. And it is this one. Just have to put the solution in set bracket like that. That's it. That's an easy. Similarly here now. Now this is an inequality. Careful now. So this one now is a kicker. So you will say, okay, multiply 2 by x. They say, oh, but they tell us, they say, given that x is greater than 0, so beautiful. So because x is greater than 0, you are free to multiply by x. Simply because x is greater than 0. See, if you didn't know if x is greater than 0 or not, you have to multiply both sides by x squared. You have to ensure that you multiply both sides by a positive value. Simply because they tell us this. It means that we can multiply both sides by x. All right, so I'm going to say that. I'm going to take this. I'm going to multiply by x. Since x is greater than 0. Since x is greater than 0, right? So the less than sign stays. That's why it stays. Stays as it is. So I'm gonna get x squared minus 2x less than 15, which is x squared minus 2x minus 15 less than 0. That's a quadratic inequality. Right? So you factorize it to find the critical values, find the factors first. X and x, 3 and 5. Signs are different. Give the greater product, the minus sign. Power product is greater, make it negative. This one positive. Then now for this one, you're basically working with a smile, as the square term is positive. So it's connected to a smile where you have a negative 3 critical value here and a positive 5 from this one. And then you want below the axis. And below the axis is on a here, which is obtained by values between these 2 critical values. Right? So x in between them, the negative 3 and the 5. So the solution is that x is less than the 5, less than the 5. But at the same time, x is greater than negative 3, greater than negative 3. All right. So they did not present the answer like that. Oh yes, right. Because remember now that x is greater than 0. So because x is greater than 0, you really cannot include. You really cannot include the negatives, right? But the x is greater than 0. So you have to find the 0. It's a nice question. I like it. To find the 0 right here. So left the 0 is here. Right? And you cannot go below 0. So you have to come back this way. But it really should be greater than or equal to 0. Right? It's greater than 0. So you actually have to go greater than 0. So to find the 0 and go to the right of 0. So you supersede this. So this is x greater than 0. Because the question did say it cannot be negative. So right here now we can say but x is greater than 0. Therefore the x can only be between 5 and 0. So the answer is this one. It's a nice question. I like this question. All right. This one again is a quadratic inequality. All right. So if we can factorize it and find the two critical values, I'm going to transpose everything over that side. Flip it around. Transpose everything over here. It's going to become x squared minus x squared. So that better. All right, so x squared minus 5x minus 6 is going to be greater than or equal to 0. So this is the same thing. All I did, I transpose these over onto this side and make them negative, and then it is greater than 0. So greater than 0. And that's what it is. So if you factorize this, it will be 6 and 1, 6 and 1. I want the difference to be 5. So 1 and 6. 1 and 6, x again. And the greater one negative, so put the negative here and a positive here, greater than 0. So if we sketch it now, we sketch it right here. So the two critical values from this factor is -1. -1. I'm shading the circle there because the equal is a part of the inequality. And the 6. Right? And you want above the x-axis. So basically then it means that you want a part of the graph out here and out here, which means that you want x values to the left of -1 and to the right of 6. That's where you're going. So you want x to be less than -1, less than or equal to -1, or x to be greater than or equal to 6. So which answer is that? Less than or equal to -1 here, greater than or equal to 6 here. The union then means or. So this is the answer. Less than -1, greater than 6. All right, that's that. Next one, another quadratic inequality again. This one's going to be a smile and going below the axis again. This can factorize this 5 and 2. All right, so 5 and 2. So if you factorize this, you're going to get x minus 2, x minus 5, x minus 2, x minus 5, less than 0. So if we sketch this one again, critical values are 2 and 5. But this time now, you want below the axis. One where the values are negative, so you want under here. What is under here obtained by x values to the left of this and to the right of that, in between those two values. Right? So your x value in between them will be less than the 5, but greater than the 2. That's what you want. So this is the answer. All right, come to this guy, that's your rational inequality. All right, now your rational inequality can become a quadratic inequality if you multiply both sides by the square of the denominator. Or you have to multiply by the square of the denominator because we have to ensure that we multiply with a positive number. Because remember, if you multiply with a negative number, we have to reverse inequality sign. So to ensure that we multiply with a positive, we multiply by the square of the denominator. So multiply the right side by x minus 1 squared and the left side by x minus 1 squared. And this one will cancel with this under here and becomes a product. So it becomes a quadratic. So it's going to become a quadratic of x minus 1 times 2x plus 1 greater than or equal to 0. But there's a caveat in this because of the denominator. I have the equal in here. Possibility exists that you might put a wrong value. What it is that you have to recognize that the denominator cannot be 0. Let me put that in purple. The denominator cannot be 0. And if the denominator cannot be 0, it means that the x can be 1. X cannot be 1. You cannot have x minus 1 equals 0 because then you'll be doing the rational function will become undefined. So the x minus 1 cannot be 0. So the x cannot be 1. So the x cannot be equal to 1. So you cannot have a solution that includes x equals 1. So you have to put x not equal to 1 from this. X can be 1. Right? So you cannot have a solution that includes 1 as a value. Now, this normally would produce a smile. Right? So it will act as if you're solving it now. You would normally get a smile All right. And the critical value from this x minus 1 will be 1. But remember, because x can be 1, I'm going to put an open circle on the 1. And this will give us a negative half critical value. So I'm going to put a shaded circle there because we can't take the negative half. Right? And then this region would be referring to the section of the graph up here and up here, which are obtained by a values to the right of the 1 and to the left of the negative half. So over here will be x greater alone, greater than the 1. Remember, it can't be equal enough. And over here will be x less than this value of negative half. Let me put that further out. So this will be x less than negative half. That's what this is. So that's the solution. Can't take the 1, so they can't be any equal on the 1. All right. So so these answers not good because this shouldn't have 1 on it. So let me shade that out. Right, I don't know if it's my mistake to leave it there, but you can't have 1 on it. So this guy answer would have to be this. All right, that would have to be your answer. You can't have 1. Because if you have x equals 1, then the function or the ratio becomes undefined. Right? Becomes undefined. You can't have 1. So that would be a solution right there. 1 is less than or equal to what here, less than or equal to negative, because it includes a negative half. All right, everybody good? Look, spot check. Everybody okay? Everybody all right there?
Yeah.
All right. We'll finish up the thing there. Tomorrow come back and do some more. Finish stuff. Here's another one with the equal 0. So we have to start out by saying the denominator can be 0, right? Start out that way and say the 2 minus 3x cannot be 0. So basically, if you transpose this, you're going to give 3x cannot be 2. So the x cannot be 2 or 3, which is what this factor would give you. But the same process again, you multiply both sides by the square of the denominator, right? Same process, and so this rational inequality will become the product 2 minus 3x times 5x minus 2 greater than or equal to 0. So you have converted it to a quadratic. Remember now the denominator can be 0. Right? So again, now it will be a quadratic. Now this will be a frown. Careful now, this will be a frown because this time this, when you expand it out, you're going to put a negative. So you have to realize now that you would have a frown-shaped quadratic. You have to be careful with the horizontal axis. Now this factor, you put it equals 0, is giving me the 2/3, you know. And this factor is giving me 2/5. So it's which one greater? Right? So you know, both of them positive. So I'm having 2/3 and I'm having, well, 2/5. So clearly 2/5 is small, right? That have a larger denominator. So right here, I'm going to put the 2/5. I'm going to shade that circle because I'm okay with the 2/5. And here I'm going to put the unshaded circle because I can't leave the 2/3. 2/3 is larger. All right? 2/5 and 2/3. Right. 2/5 and 2/3, right? Good. And then I want the part that's above the x-axis. So it means that I want this part of the graph here, which is basically between those two values, between the two roots, two critical values. So I'm coming here and I'm going there. So my x has to be between them. All right. But remember now, I can't include this one, you know. So I'm not going to have a less than on that side. Right. So my x in the middle between them will be less than the 2/3 here. But the x in the middle is going to be greater than this. And one continuous interval, so I can write as one inequality. Greater than or equal to the 2/5. That's my answer. Which is the last one on this screen, actually. This one. It's in a different color. This is it. All right, that is that. So that is it right there. Next question. 7b, another quadratic inequality. All right. So they give us this quadratic. First thing you want to recognize is that it's a frown, and the one rate is less than 0. All right. So okay, I'm factor. All right. So when they give me this now, look at this now. They are giving me the option to turn it into a smile. You know? So but basically we're solving this. This is f of x. I'm gonna put this as f of x, right? So basically we get 13x minus 6 minus 2x squared. Let me zoom it up and so I have more space there. Right? Let me zoom it up. All right. So So I have really 13x minus 6 minus 2x squared less than 0. I like when my square term positive enough. I make less mistakes with a positive square term. So I'm going to multiply by a negative 1 because an inequality have to reverse. I have to remember to reverse that less than sign. Reverse the less than sign. Or you could just transpose everything over to that side. You could also do that, right? And end up greater than. Right? Could do that. So I'm going to end up with this becomes a positive 2x squared. This becomes a minus 13x. It becomes a positive 6. The sign is reversed to greater than 0. Then I just want to factorize this now to see my factors. So let's see. So I have 2x and x. You know, our factors of this 6. The sum must be 13. The sum must be 13. So it can be 2 times 6 is 12. So it can be 6 and 1. Because 2 times 6 is 12. And then it's 1x. So it's 12x and 1x equal 13x. So those are the values. And this plus tell me that the signs in the bracket are the same. They are both negative. So negative, negative, greater than 0. So I've converted a frown to a smile. So I'm now solving this. That's what I'm solving now. Result gonna be the same. So I'm gonna sketch my smile. This one giving me 6, and this one giving me a half as my critical values. 6 and a half as those values. And I want greater than 0, meaning I want part of the graph up here and up here. So I want to the right of the 6, x greater than the 6, and I want to the left of the half, x less than half. Right? So that's what I'm looking for. Greater than 6, less than half. Greater than 6, less than half. So the answer is right here. Greater than 6, less than half. This is it. All right. Simple as that. Next one. All right, this is a less than or equal to again. If it was just a less than, guys, you go down the restriction, right? If it was less than alone, because the equal wouldn't come into play. So right off the bat, I'm going to write, wherever start, that my 2x plus 1 cannot be equal to 0. So the x cannot be minus a half. So I cannot put that equal on the minus half when I'm solving it. Again, it's going to become a quadratic when I multiply it by the square of the denominator. I'm going to just end up with 2x plus 1 times 3x minus 2 less than or equal to 0. So it becomes a quadratic when I multiply both sides. I'm in the multiple choice examiner, so I have to show that work. The quotient becomes a product, right? Simple as that. And then now what are my equity? Well, I'm gonna sketch this now. I'm gonna get a smile because the x values are both positive. And I multiply it out, I'm gonna get a smile shape quadratic. So I'm sketching my smile. All right? And I can actually do it without this sketching. You can look at it and know, but let's go. So the value I'm getting from this is 2/3. So I'm going to put my 2/3 here. I'm going to shade it because the 2/3 is okay. The value I'm getting from this one is the -1/2. But I'm going to unshade the circle on the -1/2. But I cannot accept the -1/2. I want less than 0. So it means that I want values down here. So my answers are to the left of this and to the right of that. In other words, my x is between them. So my solution is that the x in the middle is less than or equal to the 2/3. That's why I shaded there. But greater alone than the -1/2. The -1/2. So that's it. So the answer is right here. That's it. All right, moving right along. This is a quadratic inequality right now. Just two simple factors again. What's happening here? Oh. So this one, you have to realize it's going to be a frown, right? Because the square term is negative. I'm going to factorize it still first. I'm going to get x. I'm going to get x into x minus, not x, 4 minus 3x. I'm going to get x into 4 minus 3x greater than 0. It's a frown. The factor, the root I'm getting from that factor is 0. What I'm getting from this one, it's 4/3. 4/3 I'm getting from this, right? I'm going to put the 0 and the 4/3 as my two critical values. I want to put that is greater than 0. So because of frown, greater than 0 means that I want it between here, which I obtain by x values to the left of this and to the right of that. So my x values are between them. So my solution is going to be that x is less than the larger value of 4/3, but greater than the smaller value of 0. And that's it. Make this 0 different. 0. And that's my answer right there. It's the last one, which is C. That's it. All right. And then the functions start right there. I want to break it there now, guys. I'm going to break it. I know people have other classes and other things to study. I'm going to break it there today. I really wish to have gotten to do more today, but that's what it is. I know it's a short time. I know people have physics and chemistry and biology in the week, so we have other things to focus on as well. So hopefully you can join me tomorrow again, same time, 11 o'clock, so we can go through the rest of it. We have the surds, logs and indices, the vectors, and the tree. We're not doing functions, right? So all these questions, the logs questions, right? All these questions. We have logs. This is coordinate geometry, circles and so on. We have vectors. And then we have the nice trigonometry. Trees. I think that will finish off everything after the trees will be done. All right. So we can meet again tomorrow. Should be able to finish quicker tomorrow, earlier. It's very important that we start early. And some person logged in a little bit late and we start waiting. Well, that is it, guys. It was a good one for you. And tomorrow, same time, I'll go and finish the paper. Okay? Which I know this document will allow you to have a very nice, easy time in the exam. So I suggest that you look over this one, look it over, share it to their friends and so on. A lot of people will benefit from it in a great way. In that exam that's coming up on Wednesday, that must be multiple choice. All right. That's it. So bye everybody. Tomorrow again at 11, we'll start back with the surds, logs, and indices, moving to the vectors, coordinate geometry, and the trigonometry. All right. So we went basically 1 hour over. Exactly. That's fine. Okay, everybody.
Yeah.
Bye, Kai. All right, cool.
Bye.
Bye-bye. Bye-bye.
Good night, sir.
Good night. Good night. All right. I'm gonna end it now.